I'm hoping that everyone is both seeing and hearing me, and we're gonna dive straight in, okay? And today we're gonna be introducing the idea of a variable, okay? A variable is something that can change, that can vary. Okay, and we're going to start off just by going right to the back. I'm hoping you've got this document. Okay, if you haven't got this document, then you're going to need to just try and, on a piece of exam paper, just try and sort of write the stuff that we need. Okay, but we're going to start off just to warm our brains up. Okay, and I'm going to ask you, if you go to this last page, the very back, to write these numbers in this circle. Now, if you haven't, as I say, if you haven't got this document, you can write them you can draw your own little picture here quickly. Just, you don't need all the circles, you just need the numbers in this order. So we've got 7, we've got 1, we've got 0, 2, 3, 5, 9, 4, 8, and 6. Okay. Now, what we're going to do is we are going to, just as I say, to warm our brains up, and we'll make it a little bit more interesting after this. We are going to take the number, and I'm going to tell you what number to start with just now. We'll do one together. All right. And then what we're going to do, we're going to call that number X. Okay. In fact, you know what? We're not even going to call it X. We're going to call it N. We're going to call it N, and N just is going to stand for number. N for number. And we're going to take that number out of the circle. Well, I'll tell you just now where to start. And we're going to take that number and we are going to add 3. So we're going to start with a nice, easy one. Okay. All right. And let's start this time. The first time let's start with the number 2. Okay. So what we're going to do now, we're going to start with 2. So 2 is N. So we're going to go 2 plus 3. 2 plus 3 is 5. Okay. Now we're going to go around here. We're going in this direction. We're going to go to 3. So now our N is 3. And you can see N is a variable. Sorry, it is changing. So the next number will be 3 plus 3. It will be 6. The next one will be 5 plus 3. It will be 8. The next time N will be 9. Plus 3, it will be 12. Then 4 plus 3, it will be 7. Okay. Then 8 plus 3, it will be 11. Then 6 plus 3, it will be 9. 7 plus 3, it will be 10. 1 plus 3, it will be 4. And 0 plus 3, it will be 3. Okay. So what? Yes. So was there a question? Sorry, you can hear I have got a bit of a cough. So I'm sorry, every now and again I might need to cough, and I'll try and mute myself and then unmute myself again. Okay, now I want us to try one. I want you to try one. Okay, this time, what we're going to do is we're going to take the number N from here, and we're going to multiply it by 2. Okay, so we're going to go 2 times by N. 2 times by N. Okay, and this time we will start with 9. Okay, so I want each of you to try and do that. I want you to fill that in. When you are finished, just raise your hand so I can see. I will do the first one for you just to make sure you know what we're doing. 2 times 9, 18.
Hello.
Yes, hi.
Hello. I wanted to ask, on what page are we on?
Page 16. The very last page. Okay, I know that's a strange place to start, but it's just to warm our brains up.
Yes.
Okay, I'm not seeing any hands up yet. Great. I'm seeing some hands now. Okay. Seeing a few. Let's just give people a little bit longer. Seeing 9. Okay. Seeing. Okay, we're going to go over it again. Okay. And hopefully we'll start to make sense of it. All right. Okay. I'm seeing 12 people have completed it so far. Okay. I'm going to give you a little bit longer. We don't want to spend too long on this. This is basic what we call our number skills, okay? And these are really, really important. These are things that you can practice. You can practice them at home with your family. You can get your family to test you on them. Okay, so I'm saying now we've got about 17, 18 people. Well done, Liesel. Okay, guys, we're going to write down the answers now, okay? And obviously, there's no point in going quickly and getting them wrong. Okay,
Yeah.
2 times 9 is 18.
Mama.
2 times 4.
Yes.
Okay, so just mute yourself. So we're hearing someone talking to Mama. Just make sure you're muted. Looks like it was Wandile. Okay, so just mute yourself. Okay, all right, I've muted you. Okay, all right. 2 times 4 is 8. 2 times 8, 16. 2 times 6, 12. 2 times 7, 14. 2, 0, 4, 6, 10. Okay, so what we're doing is we're taking the number n out of the table, out of the circle each time. The first time we added 3. The next time we multiplied by 2. Okay, now, what I want you to do now, we're going to do one more only now, all right? In fact, we'll do 2 more, all right? What we're going to do now is we're going to put some negative signs in front of some of these numbers. Okay, so just make sure you put the negative signs in front of the same ones that I'm putting. So -1, -2, -5, -4, and let's go with -6. So some of them are negative, all right? Now, what we're going to do this time, we are going to, I'm not telling you where to start yet, all right? We're going to multiply by -3. So we're going to take -3 times n. N is going to be the number from the circle. Now, the reason we need to practice this is because one of the topics that we did in grade 8 in term 1 was integers, all right? And let's quickly remind ourselves. Maybe someone can just unmute themselves and tell me what happens when we multiply a negative by a positive.
Hello, sir. Can you hear me?
Yes. Yes.
So what happens if you multiply a negative by a positive? It will stay negative.
Yeah. Well done. A negative by a positive is negative, and a positive by negative?
A positive by negative will
Positive.
still be negative.
Still be negative, and a negative by negative?
Positive.
Positive. Okay. And lastly, a positive by a positive, what would that be?
Positive.
Positive. Okay, great. Thank you very much. Just mute yourself again. Right. So we're going to do this now. So just, I hope everyone understands what we're doing. We're taking the number out of the circle, all right, as our start number, and then we're multiplying that number by -3, and we're writing our answer down. Then we're getting the next value for n. N is a number. N is a number that can vary, okay? Vary means change, okay? And it's actually, n is what we call a variable. Okay, it can change. And we're going to talk more today about variables because they're really, really important and they're a big part of grade 8 maths. Okay, let's just do this one. I'm going to give you a very nice, easy number to start with, and that is 0. Okay, so -3 times 0 is definitely going to be 0. Okay, now I'll go to -3 times -2. Right, when you're done, put your hand up. Some of you have already got your hand up. You might want to take your hand down just by clicking on your hand, because I don't think you've finished yet. Yeah, I see some hands going down. Well done. All right, we have got, okay. When you finish, put your hand up. Okay, there are some new hands going up now, so I'm thinking people might be finished. Yeah, there's quite a lot of new hands going up now. All right, I'm going to ask Darian Webster just now to unmute and to tell me your answers, Darian. Okay, but just wait a little bit because I want to give more people a chance to try. I'm going to wait for about 20 people to finish. Okay, I think we've got 10 so far. Okay, I see 21 people have finished. Darian, do you want to tell me what you got after the 0? So just unmute yourself. I think it's Darian. Yeah, maybe it's Damien. I don't know. No, Darian. Okay. All right. I'm going to ask someone else then. Just and I don't want everyone to unmute themselves. Let's ask Masintle. Okay, I'm hearing people unmuting themselves. Let's see if this is going to work, guys. Otherwise, I'm just going to need to do it myself. Someone have a go. Hopefully not everyone have a go. Right. What's your next answer?
Greetings, everyone.
Hi. Okay, give us your answers.
Okay. It's 6, -9.
6. Just go not too fast. 6, -9, because I'm checking as I go. Yes.
15, 27.
Yes.
-27.
-27. Yeah. So I didn't hear that.
12.
12. Yes. Next.
-24.
Well done.
18.
Yeah.
-21.
Well done.
3.
3. Well done. Okay. Guys, just mute yourselves again. Okay. Please just mute yourselves again. Otherwise, it's not going to work. Okay. Great. Okay. All right. Please mute yourself. Okay. Guys, if you're not muted and you're talking to your mother or your sister or something, we all hear it. Okay. So I'm hoping you know how to mute yourself. You just click on the little picture of the microphone. Okay, well done. That is really, really important. Now, guys, you can practice this stuff. You can practice it when you're driving down the road and you see a car number plate. You can add up the digits. You can multiply the digits. Okay. Practice it, learn it, become very good with number. Okay. Now, what we're going to start off today, we're now going to go to the beginning of the book, okay? And we're going to talk just a little bit about exponents, okay? All right. So there's a really important idea. Firstly, is what is an exponent? Okay, an exponent is when we've got a number and then we've got another little number on top of it. And that little number on the top, that b, and notice we're using a variable again here, b is what we call the exponent. We also call it a power or an index, but not very often. Okay, the big number at the bottom is called the base. Okay, the base. Okay, now, who can tell me, when you see this, if you see 5 squared, who can tell me what does that mean? What does it mean if we say 5 squared? The recording is being the session is being recorded. Someone asked about that. Yeah, just quickly unmute yourself and answer. Yeah, and if someone's answering, then don't also answer. Okay. 5 squared, what does it mean?
5 to the power of 2.
Yeah, 5 to the power of 2, but what does it actually mean if we want to calculate it?
5 is multiplied by 2.
5 is multiplying? No.
5
What's 5
times
multiplying?
5.
Yeah. Okay, guys. It's 5 times 5. Okay. It's not 5 times 2. Okay. It's not 5 times 2. It's 5 times 5. Okay. All right. So now a really important idea is that exponents come first. So now we might remember from grade 7, we might remember BODMAS. Actually, we've got E E BODMAS. Okay, and that E stands for exponent. Okay.
Exponent.
Okay, so now, if we've got 2 times 3 squared, we mustn't go 2 times 3 and then square. We must first work out what is 3 squared, and then we must multiply by 2. Okay, so what is 3 squared?
6.
What is
9.
3 squared? Yeah, so guys, I was
Nine.
very
9.
scared. I was very scared I was
3
going to hear
times 3.
6. And I did hear 6. 6 is not right. 3 squared means 3 times by itself. 3 times by 3, it is 9. It is not 6. Ahí corriendo. It doesn't work like that. Okay. All right. So 2 times 9 is what?
18, sir.
18. Okay. All right. Now, this one here is really important. And I've put it here because often many people will say to me, -2 squared. They're going to say, oh, when you multiply a negative by a negative, you get a positive. Okay. That is true. But the exponent happens first. So what happens here is we square 2 and we get 4, and then there's a negative in front of it. -2 squared written like that is -4. But if we write this, -2 squared, that now means multiply -2 by itself. And if we multiply a negative by a negative, we get positive 4. So I want you to see the difference between this and this. They are written differently. The blue one says square 2 and then make the answer negative. The yellow one says
2.
square -2. And to square -2 means you are going to multiply it by itself. Okay. Now, there's lots of laws for exponents. All of them make sense. Maths always makes sense. Okay. Wiskunde maak sin. Isibalo zitleke injalo. Okay. It always makes sense. So we're going to write down in words in English here. Okay. When we multiply numbers, okay, I'm going to write numbers just in case people are not sure about that. Numbers. When we multiply numbers with the same base, we add the exponents. Okay. So when we multiply numbers with the same base, we add the exponents. Right. Now, I'm going to show you some examples of this. Okay. So, for example, if we've got 2 cubed and we multiply by 2 squared, okay. How many 2's are there over here? Multiply. What does 2 cubed mean? It means
2 times 2.
2. Well done. 2 times 2 times 2. Okay. And how many? So that there, that yellow piece is all of that stuff. Now, what about the 2 squared? What does that mean?
2 times.
Well done. It means 2 times 2. Okay. So these, sorry, guys. I didn't want to write that there at all. I did not want to write that there. I wanted to write that over here. Okay. Those green 2's, that 2 squared is that bit. Now, how many 2's are there altogether on this line with the green and the yellow?
5.
5. And what's our short way of writing 5 2's multiplying together?
2
to the power of 5.
2 to the power of 5. Okay. Hala. Okay. All right. So, guys, does it make sense? Of course it makes sense. Okay. If I gave you, and I don't want you don't need to write this, but if I gave you 2 to the 300 times 2 to the 10, I'm hoping you wouldn't have to write out all these twos. How many twos are there here?
5.
Multiply. There's
300.
300 over here. And over here?
10.
10. So how many are there altogether multiplied?
310.
310. So it makes sense that we just add the exponents. Okay, so that's our very first rule. Okay, the next rule. When we divide numbers with the same base. Okay, please try and mute your microphones, guys.
Besides, your mic.
Okay, so let's have a look at this. If we've got 3 to the power of 7, and we were to divide that by 3 to the power of 3. Okay, who can tell me what does 3 to the power of 7 mean? What does it actually mean?
3 is
times three.
repeated.
Yeah.
3
7.
times by
What?
itself 7 times.
Beautiful. 3 times by itself 7 times. 1, 2, 3. We got 3 so far. 4, 5, 6, 7. Okay. All right. And 3 cubed means 3 times by itself 3 times. Okay. Now we know from our fraction work that we can divide by 3 on the top and by 3 on the bottom. And we can do that again. All right. And we can do that again. Now, how many 3s have I got left?
4.
I've got 4 3s. And what's the short
Four.
way? What is the short way of writing 4
3 to the
3s?
power
3
Hello,
to the
hello,
power
three.
of
Well
4.
done. 3 to the power of 4.
3 to the power
And what do
4.
you? Well done. Okay. And what? Okay. All right. And what we can see, guys, is that all we are doing to get the 4 is we're just subtracting. Again, you don't need to write this down on the side here. But if we had 5 to the power of 20 over 5 to the power of 18, we don't want to write this out, but on the top there would be 20 5s. On the bottom there would be 18 5s. If I divide one out, how many would be left?
What the?
22.
There would be two.
Two.
There would be 2 left.
Two.
Okay. And so what this rule says is that when we divide numbers, we subtract the exponents. Okay.
Yeah. Yeah.
Okay. Now the next one. The next rule we're going to do.
To get it, guys.
So I didn't hear that, but guys, yeah, please mute yourselves if you're not asking a question or okay. All right. There are some hands up. Maybe just put your hands down if you're not wanting to ask something. Now you'll see these rules here that we're explaining. We're explaining them in English and we're doing examples, but you'll see them written here with algebra. Okay. And maybe the algebra is a bit confusing to some of you at the moment. Okay. But so this is now.
It is.
Okay. But we don't worry. It will get better. Okay. When we multiply, sorry. When we raise a product, when we raise a product to a power, both the factors, both the parts of the product. Okay. I've used the word power here, and I'm going to change the word power. I'm going to change it to exponent. Okay. So when we raise a product to an exponent, both factors get the exponent. Okay, so I'm going to show you something here. If we've got 2 times 5 and we want to cube that, what does it mean to cube something? It means to times it by itself twice. 3 times. Does everyone see that that's what that means? When you've got something cubed, you're going to multiply it by itself. 1, 2, 3. Okay. Now, if I look at this and I rearrange the order of this, how many 2's have I got altogether multiplying here?
3.
3. And I can write that like that. How many 5's have I got multiplying altogether?
3.
3 as well. So I can
3.
write. So I can write that like that. Okay, so what we will see. Okay, what we'll see is that when we've got a product raised to an exponent, each piece must get the exponent. Okay, guys, please try and mute yourselves. Okay, all right, because normally I have my system muting everyone. Okay, and I don't seem to be able to do that today. Okay. I can actually try. I can say mute all. Okay. Okay. All right. I have muted everyone in the hopes that we have a little bit of silence now. Okay. So the next one. Okay. If you look at how this is written with the variables. Okay. A to the B. Sorry. A times B. A and B are just numbers. Okay. A is a number. B is a number. Notice that both of them get the exponent of C. Okay, now when we raise a quotient, now guys, a quotient is a fraction, a division to an exponent. Both the top and the bottom get the exponent. Okay, if you look at it over here, we've got this fraction a over b. It's being raised to the exponent of c, and both the a gets the c and the b gets the c. That, again, we can show this with numbers. We can show that it makes sense. Have a look. If we've got 2 over 5 and we raise that to the power of 4, what does it mean to raise something to the power of 4? It means to multiply it by itself 4 times. Okay, now, if we just look at the top, how many 2's have we got multiplying all together? 1, 2, 3, we've got 4. And the way of writing 4 2's, no, 1, 2, 3, 4. Okay, how many 5's have we got multiplying together? Also 4. And the way we write that is that. So you can see these rules make sense. All right, this says if you've got a fraction, both the top and the bottom get the power. Okay. All right. Now,
it is a bit down. I'm still here.
okay, guys, guys, you need to mute yourself, please. I'm just muting everyone again. All right. Okay. Now, this one, okay, when we raise a number,
even Goofy has a Goofy.
when we raise a number with an exponent
name.
to an exponent, we multiply the exponents. Okay. All right, guys. So what I'm gonna try now, I'm gonna change the setting on the meeting, okay? And I'm gonna actually mute you all so that you can't unmute yourselves. I will be able to unmute you. So now if you have got a question, you must type it into the chat. All right. Or you can put your hand up. But as I say, I'm trying to do the teaching and monitor the chat. So I'm turning these some settings off here. Okay, so now I don't think you're going to be able to unmute yourself. Okay. Try and keep your hand down unless you've got a question. So in other words, at the moment I see Happy's got a hand up. You just click on the hand. Thanks, Happy. I see that Langelisha's got a hand up. There's a few hands. There's still one hand up, I think. No, there's still two hands up. Langelisha's still got a hand up. If you just click on the hand, it'll go away. Okay. And I see Weziwe's got a hand up. Okay. All right, guys, if you've got questions, just ask him in the chat, and I will keep an eye on the chat. I'm going to try not to go too fast, but obviously we want to get through a lot of stuff today, so I don't want to go too slowly either. Okay, so let's have a look at this one because this one's interesting. What it says is that if we've got a number with an exponent, okay, and then we raise that number to another exponent, then we multiply the exponents. Now let's understand why this is what it is. Okay, what does that mean when we square something? Okay, and I know I can't hear your answers, but you're welcome to say them out loud yourself. It means to multiply it by itself. So 2 to the 4 squared means 2 to the 4 times 2 to the 4. Okay, now if you look at the very first rule that we said, it said when we multiply numbers with the same bases, we will add the exponents. Okay, so in other words, our answer will be 2 to the 8. Okay, now you might think, I can't remember the first rule. Well, then let's write this out in full. What does 2 to the 4 mean? What does it actually mean? It means 2 times 2 times 2 times 2. There are 4 of them. What does this 2 to the 4 mean? It means another 2 times 2 times 2 times 2. Okay, I've got 1, 2, 3, 4 from the first one. Those four, 1, 2, 3, 4 are from the green one. And these 4, and I haven't got 4 yet, are from the pink one. Okay, all right. And so if I put this last one on here, there's the 4th one. If I count them all up, I've got 8. What is 8 2's multiplying together? The shorthand is 2 to the power of 8. Okay. And then the last one, all right, the last rule. And sorry, so the way we get that 8 is we don't add these numbers, we multiply the numbers. Now, I think there is some space for confusion here. You might say, Paul, you said when we multiply, we add the exponents. That's correct. That is different to this. We've got a number with an exponent, and we're raising it to an exponent. Okay. Okay, so someone's asking me to move the screen up a bit. Okay, yeah. So I am recording this, but obviously we do need to keep going. We will get breaks, okay? So I've got a timer set on my phone and it says in 5 minutes time we're having a break, and then we'll have a 10-minute break. Okay. So we'll go for about 40 minutes and then have a 10-minute break each time. Okay. Right. So the last one that we need to do here, right, is this. And what it says is that anything to the power of 0 is 1. Any number, anything to the exponent 0 . Okay, and you might say that's a bit strange. Let's test it on our calculator here. Okay, so let's just have a look. 5, and there's our exponent button. 5 to the exponent of 0 is 1. Okay, I am sharing the screen. I see someone's asking me to share my screen, so I'm definitely sharing the screen. Okay, 5 to the 0 is 1. Okay. We're not having a break yet, so the next session will be 10 minutes after the break, but we haven't had the break yet. I'll tell you when we stop, what time the next session will start. Okay. All right, guys, 5 to the 0 is 1. 96 to the 0, it's also 1. Okay, now let's understand why. All right. Remember this rule over here. If we divide two things that are exactly the same, so for example, we know that if we divide 17 by 17, 17 learners, 17 sweets, the answer is 1. We know that. That makes sense. All right. If we divide 2 to the 7 by 2 to the 7, that answer must be 1. Okay. But this rule over here, not this rule over here, sorry, not this rule over here. This rule over here says that when we have the same bases, we are going to subtract our exponents. So our other rule says if you're dividing and you've got the same bases, you're going to subtract your exponents. 2 to the 0. Now, for this to make sense, this has to equal 1. And that's why this rule is in place. It's actually a definition, not a rule. Okay, but anything to the power of 0 is 1. Okay, now I don't want to spend too long on this, but I want you to all try just the first 3 questions, 1, 2, and 3 on page 3. Okay, and then we'll go over them in a minute or two. Okay, you don't need to give your answers. You can just leave your answers in exponent form. Okay, so someone's asked me just to go back, so I'm going to go back to there. All right. And someone's asked me to raise a little bit, but I'm not sure what they mean by that. I think they mean go back up there. I'm not sure. Okay. The session is being recorded. Surely. Okay, I'm hoping you're okay with me going forward again. I'm going to ask everyone to put their hands down. So in other words, put your hands down so that no hands are showing. Okay, at the moment we've still got 4 hands showing. So the way you get your hand down is you just click on where it says raise. We've still got 4. Okay, try and if everyone can get their hands down. No, it's still got 4. Okay, we've got 3. Okay. All right, we've still got Nokubonga with the hand up. Just put your hand down, please. And then we've got Langelishe with the hand up. And we've got Elishe. Guys, we can just put your hands down. Okay. All right, we've got more hands up. Okay. All right, that's not going to work. Okay. So what I'm wanting now is I'm wanting to look at the answer to this. Okay. The answer to this is just going to be 2, and we're going to look at how we've got the same base and we're multiplying. It's going to be 2 to the power of 5. Okay, we could work that out as a number, but I'm actually not worried about that. I'm worried about the exponent rules here. Okay, number 2. All right, now we're going to have a break shortly. I'm just going to go over these 3 questions and then we'll take the break. Okay. Number 2, we are multiplying, so we must add our exponents. Okay, now 3 to the 7 plus 6 plus 0. That's 3 to the 13 is our answer. Okay, and you might say, Paul, I didn't worry about this because this is just 1. And then you would still get 3 to the 13. It makes sense. It always makes sense. Okay, let's look at number 3. Okay, and the thing here that we're testing is the order of operations. We must not multiply the -2 by the 3. Okay, we must do the exponent first. -2 times by 9. Okay, remember 3 squared does not mean 3 times 2. 3 squared means 3 times itself. It means 3 times 3. Okay, now negative 2 times 9. Negative 2 times 9 is going to be a negative number because when we multiply a negative by a positive, we get a negative, and 2 times 9 is 18. Guys, if you don't know that 2 times 9 is 18, Nancy King cool. Okay, we have a big problem. Okay, because you need to get better with your numbers, all right? Because if you can't do the numbers easily, then trying to focus on something like exponents, which is a bit more difficult, becomes a big problem. Okay, we're going to. I've had a question here to ask. Re-explain number 2. Okay, and so, and I've also had a question about a longer break, so we'll have a look at that. So, guys, if I can just quickly re-explain number 2, these numbers have all got the same bases, okay? And so it's as simple as adding the exponents. I'm going to go and remind you of the rule, all right? The rule here, when we multiply numbers with the same base, we just add the exponents. Okay, all right, so that one's got a 7 on, that one's got a 6 on, and that one's got a 0 on. So when you add them, you get 3 to the 13. What I did say is that from the last rule, this piece at the end here is just number 1. Okay. Right. I'm seeing a question with when we multiply, when we times a negative with a positive, does it equal a positive? No. A negative times a positive is a negative. Okay. When we multiply, watch my hands. When we multiply 2 negatives, we get a positive. But if we've got a positive and a negative, we get a negative. Okay, guys, we're going to take a break now. All right. I know people are wanting kind of a longer break. Okay. The problem if we have a longer break, we're just going to get through less today. What I will do is I'll make sure that I think I'll make sure that we share this recording. It will be shared on social media, and I'll show you where when we finish. Okay, but I think we should have a 10-minute break now. We haven't been going that long. All right, it'll just enable you to just get maybe a drink of water, go to the bathroom, whatever. And so we will start again at 9:57. Okay, all right. I'll write the time on here. We will start at 9:57. Yeah, I'm seeing someone saying, please don't make the break 20 minutes. Okay, 9:57, guys. Okay. I appreciate the fact that you're here on a Saturday morning working hard. Well done. Okay, but let's not take too long a break. I'll see you online at 9:57. Okay, great. Okay, guys, so it's 9:57. We're going to carry on. I'm setting a reminder on my phone for 40 minutes time, and that's when we'll take our next break. Okay, now we're not going to have time today to do all of these questions. So I want to try and do a mix of questions that involve the different rules. Okay, so if we look at question 6 quickly, all right, what we've got here is we've got a product, okay, a product, 2 things raising to the power of 7. And just to remind ourselves where that appears in our rules, if we scroll back here, that's the rule over here. This rule that I'm highlighting now with green. Okay. When you've got a product raised to an exponent, then both the things must get the exponent. So our answer here is going to be 3 to the 7 times by 5 to the 7. Okay. Right. I want us to look at number 7 because it's actually a similar idea. Okay. But this time we haven't got a product, we've got a fraction. And we need to remind ourselves which one gets the power. Do they both get the power? All right. Or does just the top one get the power, or does the bottom one get the power? And again, if we're not sure, we go back to the rule and we have a look. When we've got a fraction raised to a power, both things get the power. Okay, so have a look here. A over B to the exponent of C. The A gets a C and the B gets a C. Okay, so answer here, 2 to the power of 3 over 3 to the power of 3. Okay, now this next one is where there's room for confusion, okay? Because people might say, oh, here's a 2 and here's a 3. Let's multiply those and get 6. It doesn't work like that. Akunjalo neze. Okay? What we need to look at, we need to look at the same bases. Which numbers have got the same bases? Because if we go and remind ourselves in the very first rule, it says when we multiply numbers with the same base, then we add the exponents. Okay, so let's have a look here. Which of these numbers have got the same base? Well, those two have got the same base. Remember, the base is 2 and those 2. Okay, so when we multiply those two, we are going to add their exponents. Remember what 2 to the 6 means? It means 6 2's multiplying together. So we've got 6 2's, and then we're multiplying by another 4 2's. How many 2's have we got multiplying all together? We've got 10. Okay, we've got 10 2's multiplying together. All right, and then how many 3's have we got all together? Well, there's 7 over here. 7 3's multiplying together and 2 3's multiplying together. So in fact, we've got 9 3's multiplying together. And the way we write 9 3's multiplying together is 3 to the power of 9. And we just stop there. We cannot multiply this 2 by this 3. They are different things. Okay. Now I've seen a question, why did we skip number 4 and number 5? Okay, we're skipping 4 and 5, guys, because they're actually similar to ones that we've done. Okay, right? They are important, and I can quickly write the answers down to them. Number 4 would be 2 times 5 squared, and what we're testing here is that you know that you do the exponent first. All right, 5 squared would be 25. So we do that first, and then we get an answer of 50. And notice that this is a very different thing to 5 times 2 squared. This one would be 5. We do the 2 squared first, and then 5 times 4 is 20. But 5 times 4 is 20. So very different. 5 times 2 squared and 2 times 5 squared, different answers. Okay. All right, guys, there are loads and loads of these. And as I say, we're not going to do them all. I don't want to spend too long today on exponents. We've been going for an hour already altogether. And exponents is not, it's not a very big piece. And it is a piece that we'll come back to a bit later when we get into some algebra. Okay. I'm going to look at number 10. All right. And so number 10 looks a bit more complicated, but okay, we don't add the bases. All right, we add the exponents. Okay, so I'm seeing a question there. Look here, the 2 and the 2, we don't add the 2's, we just add the exponents. So 6 and 4 gives us 10. Right. Okay. Let's look at number 10. On the top, we've got a whole lot of 6's multiplying together. All right, lots of them. Okay, I see someone asked me to do number 9. Okay, guys, I promise you we're not going to have time to do all of them today. Number 9 is easy. Okay, number 9 is easy because you're dividing, and what happens when you divide? You're going to end up subtracting your exponents. So it will be 7 squared. Okay, just 4 minus 2. That's our second rule. If you go back to the page with the rules on. Now, number 10 is important because it involves 2 rules, 2 different rules. On the top, we've got multiplying. All right. And what happens when we multiply and the bases are the same? What do we do to the exponents? That's right. We add them. So on the top, I get 6 to the power of 20. 12 plus 8 is 20. On the bottom, I've still got 6 to the power of 4. Now I'm dividing, all right? So what are we going to do now when we divide? If the bases are the same, what are we allowed to do? We're allowed to subtract our exponents. 6 and 20 minus 4 is 16. Okay. Do you see, if you can't do the basic number stuff like 12 plus 8 and 20 minus 4, then this stuff's going to be difficult for you. Okay, we're just applying some quite straightforward rules here. Okay, now this one over here. We must do this division. Okay, and who can remember what happens when we divide? I wish I could keep you guys unmuted, okay, and that you could answer the questions. But what happens is that unfortunately everyone just keeps unmuting themselves and talking to their friends and talking to the dog, and then the dog barks, and yeah. All right. So guys, what happens when we divide exponents like this? We divide numbers with the same base. We're going to subtract the exponents. So this piece over here is going to be 3 to the power of 4. All right. That's just that yellow piece. Okay. Well done. I saw someone, yeah, typing into the chat's also good, guys, because then I can monitor that. And now we now need to multiply that by 3 to the power of 5. So now when we multiply, what do? We're going to take our bases are the same, so we leave the base as it is, and we multiply, so we add the exponents. Okay, well done. All right. Okay, this next one is actually interesting. Okay, it's a little bit of a problem-solving one, because now we have not got a rule for adding things. Okay, right, but what happens if we add two things that are exactly the same? All right, I'm going to give you an example. 5 plus 5. Do you agree that we could change 5 plus 5 to 2 times 5? Same thing, huh? All right. So here, instead of saying 2 to the 6 plus 2 to the 6, I'm going to say 2 times 2 to the 6. Okay. And now I am multiplying, and I've got the same base. Okay. So I'm going to add the exponents, and something that we haven't really said so far, but when we've got a number that doesn't have an exponent on, that exponent is actually a 1. Okay, and now because I'm multiplying, okay, I'm going to add the exponents, and I get a final answer of 2 to the 7. Okay, all right, now we nearly, yeah, we're kind of getting there with this. Okay, number 13. Now, number 13 looks scary, okay? I'm just seeing what the question was here. If we add then minus, you're talking about this question over here. If you add then minus, then that's fun. Yeah. That's right. 6 to the 16, yeah. Okay. All right. So, guys, look at this question here. It looks scary because it looks very big, okay? But if we just keep calm, what we're looking for is we're looking for numbers that have got the same base. And let's ignore the bottom for now. We're just going to worry about the top. Okay? So just the top of this fraction. This number over here and this number over here have got the same base. Okay? So what we can do, we can add the exponents. 3 to the 8 plus 11, 19. The 2's have also got the same base. Okay. Those 2's have got the same base. So we're going to add the powers. All right? And 2 to the 5 times 2 to the 6, 2 to the power of 11. Now, I can't do anything here because the bases are not the same. Okay, now I'm going to go to the bottom, and let's do the same thing. Let's look at what bases are the same on the bottom. There's some 2's, and there's some more 2's. How many 2's are there altogether? There are 9. There's 7 over here and 2 over here, so there are 9 2's. Okay, those are coming from those 2 pink ones adding together. Okay. How many 3's are there on the bottom altogether? Well, there's 9 3's multiplying there and another 10 3's multiplying there. So altogether, there are 19 threes multiplying together. And the way we write that as a shorthand is 3 to the 19. Okay. Now, what do we do now when we've got division? Okay, with the same basis. Okay, so I'm going to rub out all this highlighting, and I'm going to highlight again. Oh, goodness. Sorry. Okay, I didn't want to do that. Okay. Here we've got the same base, the base of 3. Okay, so we're going to minus. That's right. So I see someone saying they're minus. So it's going to be 3. Now, 3 to the 19 minus 19 is going to be 3 to the 0. And the 2 is going to be 2 to the 2. All right. But what do we know about anything to the power of 0? Anything to the power of 0 is just 1. So our final answer is just 1 times 2 squared. Our final answer is just 2 squared. Okay. So all we're doing here is we're just using our laws of exponents. Okay. Well done. All right. I'm seeing a lot of people responding in the chat, which is great. Okay. Someone did ask why we put 2 to the power of 1. Okay. When you write any number is just to the power of 1. So 5 is exactly the same as 5 to the power of 1. Okay. And I'll just show you on a calculator. Okay. So if we take any number and we raise it to the power of 1, we just get that number. Okay, so every number's actually got an exponent of 1 on it. Okay, now, this question over here, number 14, okay, it has got, yeah, okay, I'll give you a bit of time to try number 14 on your own. Someone said, can you try it on your own? Okay, what I want to just remind you of with number 14, I'm going to highlight some things in blue here. Those numbers that are in blue are normal numbers, okay? They are normal numbers. They have not got exponents on them. So they're just going to multiply with each other like normal numbers. The other ones have got exponents on, okay? Just take a little bit of time and try number 14, and then we'll go over it. Okay, so I want to ask why we put 3 to the power of 0 and not just 3. 3 to the power of 0, okay, is 1. We can't put 3. 3 to the power of 1 is 3. That's a different thing. Okay, I saw that someone else said here, these numbers are exactly the same, and so we can actually cancel them. So we can, here, we could have just said, let's just divide those out. Okay, and then you get exactly the same final answer. Right. But the rule says that when you divide, you subtract your exponents. Okay, I'm gonna try and see if someone could just raise their hand if they'd like to try and do this question. Okay. All right. I'm seeing, okay, TJ. I'm gonna try and unmute you, TJ, and I'm gonna see if you can explain the answer to this one. Okay, sorry, I don't think I've unmuted and Seeker, but no, TJ, I don't know. I've unmuted someone. I don't know who I've unmuted. TJ, I think. Okay, maybe not. Okay, I'm going to try and unmute someone else. I'm going to try and unmute in Seeker. Okay, guys, I'm allowing you to use your microphone. So in Seeker, just try and see if you can unmute yourself now and tell us. Okay. Not working. All right. Okay. So, right. So guys, I'm just trying, I want to try and see, just put your hand up if you think you know how to answer this question number 14. I'm just looking for someone I can unmute. Maybe you could, TJ, just try to unmute yourself and talk, because I did allow you to use your mic. Okay. All right. No one's, I'm not hearing anyone. Okay. Okay. All right. Okay, guys, I'm gonna do it myself. I was hoping one of you could show us how to do it. Okay. I'm gonna do the top first. On the top, I've got a normal 4 and a normal 6. 4 times 6 is 24. Those have not got exponents on. Now I'm going to look for all the numbers that have got an exponent of 2 on. Okay. And over here, I've got 2 2s. And here, I've got 7 2s. All together, I've got 9 2s multiplying together. Now I'm going to do the 3s. I've got 3 2s here. And I've got 7 2s here. Sorry, 2 3s and 7 3s. Altogether, I've got 9 3s as well. So that is how the top simplifies. All right, now the bottom, I'm going to multiply the normal 8 by the normal 3, and I get 24. Now I'm going to look what powers of 2 I've got. Okay, and the powers of 2, there's 2 to the 4 and 2 to the 5. When we multiply 2 to the 4 by 2 to the 5, we're going to add those exponents, we get 2 to the 9. And now I'm going to do the 3 to the 6 times the 3 to the 2. The 3 to the 6 times the 3 to the 2, add the exponents, I get 3 to the 8. Okay. So now I can divide this 24 by 24. It goes in once. I'm dividing the top by 24 and the bottom by 24. When I divide 2 to the 9 by 2 to the 9, it will divide out exactly. You might say to me, Paul, isn't it 2 to the 0 because we subtract the exponents? And you are right, it is 2 to the 0. But what is 2 to the 0 anyway? 2 to the 0 is just 1. Okay. And what will my exponent be on the 3s if I divide 3 to the 9 by 3 to the 8? All right. Remember what I'm going to do when the base is the same, I'm going to subtract the exponents and I get 3 to the 1. Okay. My final answer, guys, is 1 times 3. 3 to the 1 is just a normal 3. My final answer is just 3. Okay. All right. So, guys, what we're going to do now, we're going to leave exponents. Okay, and I know we haven't done the last 2 questions. We're also not going to talk about scientific notation at this stage. Okay, we're going to move on and we're going to look at some number patterns, okay, because they take us into some algebra that's actually really important. Okay, and I do want to have the opportunity to explain. It says, what if you did not multiply the 4 and the 6 in the top? You must multiply the 4 and the 6 in the top. You can't leave them out. Okay. Right. So they've got to be there. Okay. Okay. The whole class ends at 1 o'clock, guys. All right. Okay. So we're gonna go to page 5 now, which is number patterns. Right. And we're looking for patterns between these numbers to try and see if we can give the next 3 terms. Okay. So the sorts of things we might be doing, we might be adding numbers, we might be multiplying by numbers, we might be subtracting numbers. There might just be a pattern of numbers that we should recognize. Okay, let's have a look. Okay, the first one. Yeah, so someone wants me to go back. All right. Yeah, guys, the problem with going back, if we go, I will go back just briefly. Okay. But if we keep going back, then we're not going to get much done. Okay, I am recording the session, Okay, and we'll make sure that we put the link to the video on social media so you can watch it again if you want to. Okay, so I'm now seeing some people are saying thank you. All right, and I'm seeing people starting to answer question 5. Page 5, and saying that we're adding 4, and that's absolutely right. Hala. We're adding 4, so the next term would be 19. 19 plus 4 would be 23, and 23 plus 4 would be 27. Okay, all right. This one over here. Guys, at the end, I will explain where you could find the video recording. Okay. This one over here we are. What are we doing? You can just type in the chat. Sorry, guys. All right, guys, we're on page 5. And now I'm seeing people answering this correctly. We're timesing by 2. So this would be 32. 32 times 2, 64. And 64 times 2, 128. Okay, great. What about this one? Now, this one's not as obvious because we're not adding or multiplying by a fixed number. But can anybody write down just in the chat, what are these numbers? These are actually quite special numbers. All right. We're on page 5, guys. Page 5. All right. These are quite special numbers. Anybody know? You're well done. They are square numbers. Okay. This is 1 squared. This is 2 squared. This is 3 squared, 4 squared, 5 squared. 6 squared is 36. 7 squared is 49. And 8 squared is 64. Okay. Right. Important numbers, square numbers. You need to recognize them. Okay. What about this next one? 19, then 13, then 7, then 1. What's happening here? Okay, someone's asking what are square numbers? Square numbers are when you just square the numbers. So 1 squared, 2 squared is 4, 3 squared is 9. Okay, this next one we are minusing 6. Well done, I see it in the chat there. So 1 minus 6. Now, if you can't do, we're not dividing by 6 here, we're minusing 6. All right, if you can't do integers, guys, I want you to think on a number line. 1 minus 6 is actually minus 5. Minus 5, minus 6, minus 11. Minus 11, minus 6, minus 17. Okay. All right. Okay, well done. What about this one? We're going from 1,000 to 100 to 10 to 1. What are we doing here? Well done. We're dividing by 10. All right. Well done, John. Okay. And also Ogushe. Okay. So if we divide 1 by 10, we get a 10th. If we divide that by 10, we get 100th. And if we divide that by 10, we get 1,000th. Okay, in term 1, we actually did decimals as well. So I'm hoping that you guys know that 1/10 is 0,1. 100th is 0,01. And notice that the decimal point is just moving. Yeah, the number, we're putting one more 0 in each time, and this one would be 0,001. Okay, what's happening here? All right, this one's a little bit interesting. This one's a little bit difficult, maybe. How much are we adding to get from here to here? We're adding 1. Well, okay. We're not adding the consecutive odd numbers, but we're adding to get from here to here, we're adding 2. And to get from here to here, we're adding
2.
Yeah, and then 3, and then 4, and then 5. So now I must
5.
add
6.
6. Yeah, okay. Zika, it looks like I did manage to allow the use of your microphone. Okay. Just mute yourself again for now. That's right. We're adding one more each time. So if we added 5, now we must add 6, we'll get 22. Then we must add 7, we'll get 29. And then we must add 8, and we'll get 37. All right. Guys, I'm hoping you're starting to realize that if your numbers are not good, then this is going to be, it's going to be difficult. Okay. Now, what we want to look at now, we're going to look at some patterns here. Okay. And so we've got these different figures, different diagrams, and the first part, just filling in the table, is quite easy, I think. How many small squares are there in figure 1? There's just 1. Okay. We can see 1. And in figure 2, there are 1, 2, 3, 4. In figure 3, there will be 9. Okay. Now, we've already come across these numbers today. Do we need to draw figure 4 to get the answer for figure 4? What is, are you asking for the rule for this one here? We add one more each time. Okay, we don't need to draw the diagram for 4 squares. How many little squares will there be in 4 squares? In figure 4. Well done. There will be 16. Now, guys, this is where algebra starts to come in here, okay? Because who can tell me, and maybe you can just type it in the chat, how do we get from the figure number to the number of small squares? What do we do? What do we do to get from here to here? From here to here. From here to here. Well done, we square it. So this answer will be 5 squared. It will be 25. Figure 9. Well done, guys. I'm seeing quite a lot of so I asked this, someone asked, what do you mean by no? Okay. So I asked, do we need to draw the diagrams? We don't need to draw the diagrams. Figure 9 will be 9 squared. Well done. Someone said 81. They're 100% correct. Now, what we want to do here is we want to work out how would we go backwards? Which figure number will have 144 squares? Okay, well done. Okay, I'm saying figure number 12. Okay, and the reason it's figure number 12, okay, guys, to get from the figure number to the number of small squares, we are squaring. The undoing of squaring is square rooting. So if you want to get from the number of small squares to the figure number, you're going to square root. If you're going this way, you're going to square root. Now, we're speaking English at the moment, okay? If we are talking figure n, then how many small squares will there be? Now, we don't want to put a different number here, but what's the rule? What do we do? What did we do to 12? We squared it. So what must we do to n? We must square n. Okay. Now, a whole lot of you, hi, Connor, Paul, what are you saying? Why n squared? What is n? N can be anything, guys. N can be any number. If n is 5, here's 5, then we square 5. If n is 2, then we square 2. Okay. If it's n, we write n squared. Okay. Now, what must I write here for p? How do I go backwards? What must I write if I've got p small squares? What figure number am I dealing with? And I'm just seeing if anyone can type in an answer here for this one. Okay, it won't be p squared, huh? It won't be p squared. I'm going the other way. It will be the Melissa. Well done, Melissa. Markham, very nice. It'll be the square root of p. Okay. All right. And so, not p squared, guys, square root of p. Okay. Well done. I'm seeing quite a lot of you getting that right. Okay. So the thing is that a lot of you are being freaked out by many of you are comfortable with the numbers, but you're uncomfortable with the algebra. The algebra is just letting the letter take the place of a number. And that's why what we're doing now is really important. We're going to do another one. I'm going to ask you to try and complete this table, okay? How many, we'll just do the first one together so we make sure we know what we're doing. Figure number one, how many triangles are there? Just one. Ellie Lordberg. How many lines have we used? 1, 2, 3. We've used 3 lines. Okay. All right. Do figure number 2, figure number 3, and then I want you to see if you can work out how many triangles will there be in figure number N, and how many lines will there be in figure number N. Okay, someone's asking me to just explain the square root idea again. Okay, it's just going the other way. So how do you get from 3 to 9? Use square. So to go this way, use squaring. And the undoing, going backwards, you go to square root. Okay, so you're going to find the square root. So if you've got p, you go to the square root of p. If you've got n, you go to n squared. Okay, I'm seeing some answers here. In figure 2, there are 2 triangles and there are 5 lines. That's exactly right. Figure 3, there are 3 triangles and 7 lines. Figure 4, there are 4 triangles and 9 lines. Okay, so now we're looking for patterns here. All right. Figure 5, absolutely, there are 5 triangles. We haven't got the figure, guys. We haven't got the figure, but we can figure it out, okay? Because we're just adding a triangle each time. And how many lines are we adding? Yeah, the rule for the lines is +2. That's brilliant, okay? I'm just trying to see who asked that. That's Kumbuzo, okay? The rule for the lines is +2. We're adding 2, okay? So now, guys, now. So far, we've been good because it's been numbers. Now, what if there are if it's figure number n, how many triangles will there be? And so now you might say, Paul, I don't know what n is. It doesn't matter what n is. What do we notice about well done. Okay, I'm seeing someone writing n there. Okay, it will be n, guys. Do you notice? I want you to notice this number. These numbers are the same every time. 5 triangles, 5 figures. Figure number 5, 5 triangles. Figure number 3, 3 triangles. Figure number n, n triangles. Okay, now let's see if we can work out how many lines will there be. And guys, this is a little bit trickier, okay? And I'm going to give you a hint here and a little strategy here. We are adding 2 each time. Do you agree? We're adding 2. Now, if we're adding 2, I'm thinking that maybe if we take the figure number 2 times the figure number. Let's try that. 2 times the figure number. If we try 2 times 1, we get 2. It looks like we need to add 1. If we take 2 times the figure number plus 1. Let's just see if that's going to work, okay? 2 times the figure number. If the figure number is 2, then 2 times 2 plus 1 gives us 5. If the figure number is 5, 2 times 5 plus 1 is 11. Okay, so now, guys, for this one, a lot of you are wanting it to be 13. It's not 13. Okay, it's going to involve n. Okay, this here, and this, guys, this is tricky, and this is algebra. Okay, this is expressing this rule Okay. Let's just first make sure that we're happy that this rule is correct. Okay. Don't worry about how I got the rule, but is it correct that the number of lines is double 2 times the figure number plus 1? Let's just check that. Is that correct? I can see some people are saying, yeah, 2n plus 1. Some guys, we're having a break in 2 and a bit minutes time. We're finishing the whole day at 1. Okay. So let's just see now. Guys, to get from here to here, we take our number, our figure number, we multiply by 2 and add 1. Okay, I just want you to confirm with me that is working. 2 times 4 plus 1, 9. 2 times 5 plus 1, 11. Now, if there's figure number n, it will actually be 2 times n plus 1. Okay, that's what it will be. All right, guys, and the way in maths now, the way we're going to write 2 times n, we're going to write 2n plus 1. Now, a lot of you're finding this difficult because it's got the variable in it. Okay. Now, I want us to think about this. Okay. If there are T triangles, what do you notice about the numbers in this row and the numbers in the top row? They're exactly the same. So this must be T. This must be T. Okay. All right, guys, you can't see each other's faces because I've turned off your cameras. Okay. All right. That must be T. These two numbers are the same. Notice 2, 2, 3, 3, 4, 4. Okay. So if this is T, now instead of it being 2n plus 1, it will be 2 times T plus 1. 2T means 2 times T plus 1. Okay. All right. Because the rule is to get the lines, we times by 2 and then add 1. All right. Now I want to explain something to you here. Look at what's happening here. To get from the figure number, all right, to get from the figure number to the number of lines, okay, what we do is we times by 2. Okay, we're going to have a break shortly. We're going to times by 2. And that gives us 2n. And then we're going to add 1. And that gives us 2n plus 1. That's how we get from the top row to the bottom row. Now, how do we undo that? Okay. All right. This P here is the number of lines. Okay. All right. It's not 2P plus 1. Okay. If we've got the number here, guys, listen to what I'm trying to do now. I'm trying to say, how do I get from the bottom row to the top row? How do I go up there? Okay. And I want you to look at what I've written down here. And I want you to listen carefully. Okay. So when we go this way, we multiply by 2 and then add 1. Multiply by 2 and then add 1. Okay. Now, if we want to go backwards, so if we want to go this way, I want you to think about how you undo that. Okay. How do you undo adding 1? You minus 1. Okay. And how do you undo timesing by 2? You divide by 2. Okay. So let's have a look. P minus 1 divide by 2. I want you to test that, guys. If you take the bottom number and you minus 1, let's just look at this number over here. Okay. If you minus 1 from 9, you get 8. And if you then divide by 2, you get 4. This rule is taking us backwards. P minus 1 over 2, P. Okay. All right. Guys, what we should have noticed is that all of these are the same each time. These two, the top row and the bottom row. Okay. I am going to show the full page when we have a break, and we're going to have a break any minute now. Okay. All right. Guys, I know you're finding this a little tricky, okay? And because of that, I'm going to, in the next lesson, in the next section, we're going to go to another example just to try and help you understand the algebra, the piece. Okay. And guys, this stuff is so important. I know it's confusing. Okay. And I think it's going to become a bit clearer soon. Okay, guys, we're going to have a 15-minute break. So we're going to start again at 10:55. All right. I'm going to show the whole page because someone asked me to. I don't know if that's quite the whole page, but I'm showing quite a lot of the page. We will start at 10:55. Restart. Okay. Guys, it's now 10:55. So we're going to restart, and I'm going to go to I'm going to ask you to go to page 7, all right? Because we're going to try and make sense of this algebra stuff that we're dealing with, okay? That we're finding quite tricky at the moment. All right, and I'm hoping that this one will help us a little bit, okay? So what this is, it's a little machine, okay? We pop a number in, we wind the handle, and out comes our answer. And you'll see the first machine, we've got an explanation here. This is in English. It's explaining to us what this machine does. Okay, now. Right, so I'm seeing requests for another session this term. We can definitely try and make that happen. Okay, so guys, this one is going to double and add 1. All right. We're on page 7. Thank you. I see some people asking page 7. Okay. So double means to multiply by 2 and add 1. So what will happen when we double -3? We multiply it by 2 and then add 1. Maybe you just want to type into the chat here. What will we get when we put -3 into this machine and we double and we add 1? Anyone, just type your answer in there. Double and add 1. Well done, Melissa. No, so Nomfundo, and it's not going to be -7. It's actually going to be -5, okay? Because 2 times -3 is -6, add 1, -5. That's right, okay. What happens when we double 0 and add 1? Double 0 and add 1. Let's see some answers for that now. I'm seeing lots of -5 still. Well done. Obviously, that one's going to be 1. Okay. All right, next one. What happens when we double 4 and add 1? Okay, I'm not seeing any answers. Yeah, there we go. I'm seeing, thank you. Lots of you. Double 4 and add 1, we get 9. Okay, now, guys, all of this is just number stuff at the moment. We haven't done any algebra. Okay, now, I want you to think about this. What number must we double and add 1 if we want to get 41? Okay, and I'm seeing lots of you with correct answers. Okay, well done. Hala. 20. Okay. And I think what you did, all right, I think you thought, okay, before I add the 1, I must have 40. And so what must I double to get 40? Well done, guys. Lots and lots of you saying 20. 20 is correct. Okay, now, okay, the question mark was just asking what must go there. I was showing you that we're doing that question. All right. Now, guys, how can we write this in algebra? Okay. All right. So Okay, I'm seeing, yeah, well done to Wandile. Wandile's obviously well up to speed, but guys, what will we write in this box here? What happens when we put n in? What happens when we put n in? I'm seeing someone saying 2x plus 1. What's x? Okay. What when we put n in? What will come out of this machine? Okay, I'm seeing someone that said n2 plus 1, someone else saying 2n plus 1. Guys, the answer is going to be 2n plus 1. What does 2n mean? 2n means 2 times n, and then add 1. This here is algebra. And it's just using symbols. It's using a variable, okay, to get to express this English. So instead of using English, we're using maths, we're using symbols. Okay. And guys, I know lots of you are saying, why n? What is n? N can be any number. If n is 4, you double 4 and add 1. 2 times 4 plus 1. If n is 20, 2 times 20 plus 1. Okay. What if I want to go from here up to here? What must I do to go backwards? Now I want you to, well done, well done. Okay, I'm seeing different answers here. Okay, guys, let's just think about undoing. Okay, undoing what's happening here. Okay, I want you to listen very carefully. I'm going to speak in English. We are multiplying by 2 and then adding 1. We must minus 1. Well done. Reverse operations, or Guhle, 100%. We must minus 1 and then divide by 2. Let's check that, guys. If we take 9, we minus 1, we get 8, and we divide by 2, we get 4. Okay, so to get backwards, we are going to actually go p minus 1 divided by 2. All right? You might say, Paul, can I write this? You can't write this. Okay? And I don't know if anyone can tell me why this would be wrong. Okay? And I want you to think about BODMAS. This here would be wrong because this would happen first. What must we do first? We must first minus the 1. Okay, so this is wrong. Well done. Okay, this is wrong. How could I fix if I want to write it like this? If I want to write it as p minus 1 divided by 2, how could I fix it to make it right? Well done. Okay, the person who said add brackets. Halala. Okay, guys, that is also right. Either this one or this one. Absolutely. Someone's asking, or Gush is asking, the number the P can just represent any number. All right. So we've got this machine. It does stuff and it undoes stuff. Okay. Now I'm going to ask you guys to try and do this one. Now this one, the machine takes a value. Okay. And guys, these numbers are X. Okay, so each time the number at the top here is the X value. So the first one, X is going to be negative 4. This means 3 times X. Notice I've written the times and the X differently, and then minus 2. I want you guys to try and complete this table. I'm going to look for something on my computer while you do that, okay? Okay, let's have a look at, I found what I was looking for and I'll show it to you just now. All right, so some people saying done. Okay, so what happens when we put -4 in? 3 times -4, guys? -12. What do I get here? Well done, -14. Well done, Skumbuzo. -14. Right. 3 times 1, subtract 2. 3 times 1, subtract 2. Well done, 1. 3 times 5, subtract 2. 13. Well done. Okay. 3 times 8, subtract 2. Well done. I'm seeing 1 or 2 answers. I'm seeing Melissa. Okay. 22. Now, guys, what must I put in here if I want to get 28 out? Okay, guys, it's so pleasing to see lots of correct answers. Well done, Nomfundo. Well done, Skumbuzo. Okay, guys, I need to let's think, and I want us to think about undoing. Listen to my words. Listen to my language. Multiply by 3, then subtract 2. I want to go backwards. I'm going to add 2, and then I'm going to divide by 3. And I will get 10. Okay. All right. Listen carefully. Multiply by 3 times 3, then minus 2. That's what this machine does when we go from the top to the bottom. Now, let's go from the bottom to the top. We want to go backwards. We want to undo. So we want to start here and go backwards. Now, what's the undoing of minusing 2? Add 2. And what's the undoing of timesing by 3? Divide by 3. Okay, so how will I write it for G? Okay, in fact, before I go there, guys, let's just check this. If we add 2, okay, and then divide by 3, let's just check. Let's check this one. 13 plus 2 gives us 15. Divided by 3 gives us 5. It works. 1 plus 2 gives us 3. Divided by 3 gives us 1. 28 plus 2 gives us 30. Divided by 3 gives us 10. So how will I write it with G? Well done to those guys. Not G minus 2. I see a G minus 2 there. Won't it be G plus 2, guys? It will be G plus 2. G plus 2. BODMAS always applies. G plus 2 divided by 3. Okay. All right. Okay. Now, guys, I'm going to just show you something else. BODMAS always applies. Okay. So G plus 2. This here means this is like a bracket. So in other words, we do the G plus 2 first. If we write it as G plus 2 like this would be wrong. Okay, we would have to have brackets to do the G plus 2 and then divide by 3. Guys, I'm going to show you something else here now. Okay, I'm going to show you a little presentation, which I hope is going to show properly here. All right. Okay, so if we were getting dressed, okay, and I'm just going to use 3 items of clothing. I'm going to use undies, then longs, and then shoes. Do you agree that's the order that we would get dressed? Okay, we don't put the shoes on first. It's very difficult to get your amabulukwe on, your jeans on if you've got your shoes on. Okay, all right. Now, when we get undressed, guys, which one comes off first? Which one comes off first? The shoes come off first. All right. Then what comes off next? Then the longs. And then what comes off next? The underpants. Okay. All right. So when we undo with the machine, we do exactly the same thing. We undo in the reverse order. So in other words, we're working backwards. Okay. All right. Let's try another one. Okay, let's try this one. Okay, so this one is going to square. Now remember what square means. We did exponents earlier. Okay. Our input is going to be squared and then add 1. These are our x's here, our inputs. And what is x? X can be anything. In this box, x is -3. In this box, x is 0. Okay, in this box, x is 6. All right. What will come out if we put -3 in? And I'm seeing some right answers and I'm seeing some wrong answers. Okay, Nonhlanhla, you're correct. Melissa, you're correct. Okay. Unfortunately, Skumbuzo, you're not correct. Okay. When we square, guys, when we square -3, all right, that means -3 times by -3. Okay, now some of you, I think, are getting a negative answer there. That's not right. Okay, -3 times -3, guys, is 9. And then add 1. The correct answer here is 10. Okay. Right, what about 0? If you square 0 and add 1, that's quite easy, I think. Square 0 and add 1, you just get 1. 0 times 0, 0. Plus 1, 1. Okay, now, Nancy Kinga, here's a problem. What must I square and add 1 to if I want to get 5 out? And this is the dressing and the undressing. Well done, Skumbuzo, Melissa. A few of you have got this. Okay. Guys, I want to undo. Now listen to the words again. Square and then add 1. Now I want to go backwards. -1 and then what's the undoing of squaring? It is. Can someone type in there? What's the undoing of squaring? How do we undo squaring? Lots of you getting the right answer. Well done, Mfundo. We square root. So 5 minus 1 would give us 4. Square root would give us 2. Okay, so what must 6 go to, guys? What will 6 go to? If I put 6 in, well done. Okay, Mateo, not Mateo, just there's a few of you. Simkaliswe, sorry. 6 squared plus 1, 37. Well done. And what does 101 come from? What does 101 come from? Okay, I'm getting lots of nice answers there of 37. 101 comes from, well done, 101 comes from 10. Okay, so I'm going to draw an extra box in here. And I want to ask you guys, if I put G into this machine, what will come out? What? Okay, guys. So I'm leaving a gap here. Okay. Someone's asking how did we get 13? I'm not sure. Oh, you're talking about over here. And I don't know where you're talking about. There's no 13 on this one. Okay. All right. So guys, someone's answered this question here. Okay. And they've answered it correctly. They've said the square root of m minus 1. And that's absolutely correct. Guys, have a look here. If you minus 1 and then square root, you're going to get the right answer. 37 minus 1, square root, 6. 5 minus 1, square root, you get 2. Okay. Right. Guys, what would G be? Well done to, no, G, there we go, G squared plus 1. Guys, G would be G squared plus 1 because G is just going to replace the X. G can be anything. Okay. All right. Okay, guys, we're going to go now and we're going to go to page 8. Okay. I realized I didn't start a timer, so I'm just going to start a timer now. We've been going for 19 minutes, so I'm going to start a 21-minute timer just so we get our break in the right place. Okay, people are asking me to just go back briefly. Excuse me. Oh, excuse me. Yeah, this is page 7, guys. All right. And so just in words, this one squares add 1. When we go backwards, we are going to square root. We're going to -1 and then square root. Okay. Okay, someone's saying to the second question, that's this one over here. Okay. So this one we multiply by 3 and subtract 2. But when we go backwards, we add 2 and then divide by 3. All right. And I want you to think about the getting dressed and the getting undressed. Okay. All right, guys, we're going to go to page 8 because what we're going to look at now, we're going to look at, and I'm going to be very interested to see, because my prediction is that all of you can do this row and this row and this row and this row. And now this row, we may be, some of you, not all of you, some of you are going to have a problem. Okay, let's do the first row together, guys. We've got 5 hens and 3 sheep. Okay, how many eyes are there? How many eyes have they got all together? All right, anyone want to tell me how many eyes? We're on page 8. How many eyes will we have if we've got 5 hens? Okay, I'm seeing 8 eyes. Guys, these hens have got 2 eyes. A hen has got 2 eyes. Okay, and we've got 3 sheep. Okay, guys, we will have 10. Yeah, I'm saying to, no, not 10. I'm saying, no, whoa. What? Why 10? No, guys, the total number of eyes on all the animals. 16, guys, 16. All right. Because how do you find out the number of eyes? You multiply by 2 and you multiply by 2 and you get 16. Okay. I'm hoping you all okay. Now I want you to think about the number of legs, but just be careful here because hens and sheep have different numbers of legs. Okay. No, it's not 5 times 2 is 10. It's 5 times 2 is 10. And what's 3 times 2? Because the sheep have also got eyes. All right, I'm looking for legs now. Okay, I'm looking for legs. Legs, legs, legs. Legs, legs, legs. Okay, legs, legs, legs. And I'm seeing lots of right answers. There will be 22 legs. Okay. And the reason that, yeah, this is, guys, someone's saying, oh, total. Yeah, total. That's why it says total. Okay. Total number. Okay. Total number of eyes on these animals and total number of legs. The reason there are 22 legs, there are 10 legs on hens and there are 12 legs on sheep. Okay. Now, fill in the next row here. Okay. And I think you're all going to be okay with this next one. How many eyes will there be if we've got 2 eyes on each hen? We've got 2 hens, and we've got 2 eyes on each sheep, and we've got 4 sheep. Okay, this is going to be 12. All right. Well done, everyone. It's going to be 12. Okay, I'm hoping people are understanding. Guys, the two hens will have 4 eyes altogether. 2 times 2. The 4 sheep will have 8 eyes altogether. Okay, because each of them has got 2 eyes, and there's the 12 eyes. Okay. The 2 hens will have 4 legs because each hen has got 2 legs. But the 4 sheep will have 16 legs. So the total number of legs will be 20. Okay, I'm seeing lots of you getting this right. Now, okay, now is where it gets slightly more interesting because now we don't know how many sheep there are. And I need you to work out for me how many sheep there are going to be. If there's 16 eyes in total, okay, I want you to think about how many sheep there are going to be. Well done, Sipiwe. I think Sipiwe is right. Okay, so guys, what we've got to do now, we've got to think, and then maths is all about thinking. It's about using our brains, okay? I'm seeing lots of wrong answers. I'm seeing some right answers as well. Yeah, well done, Zondo. Absolutely. We need to undo what's happening. Okay, let's just think about if there are 16 eyes all together, how many of those eyes are on the hens here? There's 12, huh? 12 eyes. So that means that we must have 4 eyes on the sheep. But that doesn't mean we must have 4 sheep. How many sheep must we have? We must have 2 sheep to get the 4 eyes. Okay, now can we fill this in? Now this will be easy to fill in because we know how many hens we've got. Okay, and I'm going to write something down here. Okay, I'm going to write down here 6 times by 2 plus 2 times by 4. Okay, now guys, 6 times by 2 is 12, and 2 times by 4 is 8, and I'm seeing a lot of you saying 20, and 20 is exactly right. Okay, and I want to show you where this number is coming from. Do you see this is 6, and that's 6. Why am I timesing by 2? I'm timesing by 2 because there are 2 eyes on each hen. This 2 is this 2 over here. There are 2 sheep. Right, but each sheep has got 4 legs. Okay, so we need to multiply by 4. Right, now I want you to see if you can work backwards. If you know the number of legs, the total number of legs, and you know how many sheep you've got, how many hens would you have? Okay, I am seeing some right answers. 6 is not right, okay? 6, if you've got 6, I know where you've got 6 from. It's 6 legs, no, but it's 3 hens, guys. Let's have a look. Okay, how many legs have these sheep got? They've got 8 legs. Now, if there are 14 legs altogether, and there are 8 here, there must be 6 legs here. That doesn't mean 6 hens, okay? That means 3 hens. Well done to all of you who said 3. Okay, and if I've got this number and this number, now I'm going to write a formula in here again. I'm going to write my answer down, okay? But we're talking about numbers of eyes. Do you agree that we can take the 3 and multiply by 2, because each hen has got 2 eyes, and then we can add the 2 multiplied by 2. Okay, and what we actually get is we get 6 plus 4, we get 10. Well done. Okay, guys, I'm very impressed that you're all following along and answering. Okay, it's fantastic. All right, I hope you're not just copying each other. Okay, guys, I want to show you, look at this, and look at this number over here. Do you agree? That's the rule. Okay, that's the rule. Now, okay. Okay, now remember what I said. The first 4 rows, we've all got ticks. We're all happy. The first 4 rows are all about numbers, and you guys are comfortable with numbers. You know what 2 looks like, okay? If I say this, you know that that's 3, okay? Now we've got a variable representing the number, okay? How will I work out? And I want an algebra expression. I want a maths expression. How will I work out the number of eyes? Okay. And we're going to need to think about this quite carefully. How will I work out the number of eyes if I've got A hens and B sheep? And I want you to look at this, guys, look at this, this formula here that I wrote down. In other words, this box. Look at this box here. Halala. Okay, so I'm seeing, sorry, that goes to green if I showed that, so I don't really want to do that like that. Okay, guys, I'm seeing AB, I'm seeing 2A plus 2B, I'm seeing all sorts of things. Okay, I'm seeing A times 2. Okay, right. Guys, AB is not right. AB means A times B, i.e. equal. We're not multiplying the number of hens and the number of sheep. Okay. All right. Let's write it down over here. How many legs will these hens have? How many legs will they have? Just what must we do? What must we do to the number of hens to get the number of legs? What must we do? What did we do here? Sorry, guys. This is yeah. How many legs will they have? They will have A times 2. Well done. A times 2. Now, guys, the way we write A times 2, we write 2A. Okay? So we're actually doing I's. Yeah, we're doing I's, but in fact, these also have 2A I's. How many I's do our sheep have? If we've got B sheep, and each of them has got 2 I's, what must we do? What must we do to get the number of I's if we know the number of sheep? Well done, Nomfundo. We must multiply by 2. Okay, so these ones will have 2B I's. Okay, now if we want the total number of I's, guys, if we want the total number of I's, we must add the number of I's from here to the number of I's from here. 2A plus 2B. Okay, right? What about the total number of legs? Okay, and I'm going to ask and see if anyone can tell me what's the total number of legs going to be if I've got this many hens and this many sheep. Okay, well done, Melissa. Yeah, very nice. Okay, and Sika, you're close. And Sika, you've only given me the answer for the sheep's legs. Okay, I want the total number of legs. Okay, not 4AB. 4AB. Okay, I know why you're saying 4AB. Well done, Ogutle. Okay, I know why you're saying 4AB, but it's actually 2A. That's how many legs those have got. And these ones have got 4B legs. So the answer is going to be, we're not going to go AB, 2A plus 4B. 2A plus 4B means add those two amounts. Add the hen's legs to the sheep's legs. Okay. All right. Okay. Now, I know a lot of you found that harder. Okay. All right. We're not going to do these next rows, but if you think about them, we did similar ones. We did them with the numbers. Okay. We just because of time, we're now going to do this example. Okay. Because we need lots of different examples. Okay. Masinhle, we're doing another example now, okay, and it will start to make sense, okay. A few of you saying you don't understand, and I'm not surprised, okay, because this learners find this difficult. I suspect. I hope you understood. I hope the people who were struggling. I hope you weren't struggling with these first 2-3 rows because the first ones are just numbers, okay. All right, guys, I don't want to go back, okay? You can quickly copy those answers, and I want us to do another example, another different type, okay? We're going to do lots of different types, and I promise you it will start to make sense, okay? All right, and then you can also watch the video again, okay? Right, so let's look at a new example now, okay? So here's the taxi, okay? All right, so the taxi comes to your house and it charges 20 Rand to come to your home. And then you go for a drive and it's 4 Rand for every kilometer. Okay. So let's see if we can fill this in. And I think I think most of you can work this out. What will the cost be if we do 10 kilometers? I want you to just type it into the chat if you can find this answer. Okay. Okay, it's not going to be 40, guys. The taxi charges 20 Rand. I want the total cost, total cost. It's going to be well done. There's some of you getting it right. It's going to be 60 Rand. Hala, hala. It's going to be 60 Rand. And I'm going to write down here how that 60 is made up. It's made up of 20 plus 10 times 4. Am I right? This 10 times 4 is for the 10 kilometers. This 20 is for the taxi to get to your house. Okay. Is everyone okay with that? Okay. And what's the answer? Obviously, we must do the multiplication. We get 60. Ah, I'm seeing people say, oh, yes, yes, yes. Okay, I understand. Yeah. Okay. All right. What if I do 20 kilometers? Okay. All right. Okay. People are saying 100 Rand. I think you might be right. I want to check it. Okay. I'm going to have to pay the 20 Rand. Okay. And then I'm going to pay 20 times 4. Now, guys, 20 times 4 is 80. 100 Rand is correct. Okay. Hala. Okay. All right. Now, guys, I'm highlighting. Okay. I'm hoping you're seeing my highlights here. This here is that 20 Rand. This 20 is actually the 20 kilometers. Okay. All right. Now, we want to work backwards. Okay. We're going backwards now. If I spent 420 Rand, how many kilometers did I do? Okay. So now we need to think. We need to think. This is what maths is all about. Nsika, well done. Yeah, well done. Well done, Smbuzo. Well done, Nonhlanhla. Yeah, well done, guys. 100. Okay. And listen carefully. The way, okay, I'm seeing an 85. I don't understand where 85 is coming from. Okay, guys, think about going backwards. Let's take off the 20 Rand. And that 20 Rand that I'm subtracting is how much the taxi charged to get to my house. So on the top of this fraction now, I've got 400. Is everyone okay with that? But now that 400 is the total that I spent on driving, and each kilometer costs 4 Rand, so I must divide by 4. And you're absolutely right. This comes to 100 kilometers. Okay. Are we okay? All right. Now, everything from here above is numbers. Numbers. And as long as we have been practicing, all of us are happy. We love numbers. Okay. All right. So I'm saying, how come is 100? 20 plus 20 is 40 times 4. No, so that's an order of operations thing, okay? Because remember BODMAS, huh? Remember BODMAS? It's not 20 times 20. We must do the 20 times 4 first, okay? It doesn't have to be in brackets. 20, I'm going to put brackets in, okay? If you want brackets in, I'll put brackets in. It would happen first anyway because of BODMAS. Okay, so that's how it works out. Okay, all right. Now, guys, what we're looking at now is algebra. We're working out how can we write this rule. Guys, here's the rule. This is the rule. This is English. This over here is English. Algebra is writing the same rule, but using maths. Okay. So, guys, if I do d kilometers, what will the answer be? And I'm seeing a whole lot of you getting it right. Okay. It's going to be 20. Why 20? Well, because we've got that green 20 that we always have. Look, do you see? And I'm hoping my highlighting is helping. Remember, we always had the 20. And then what did we have? Then we had the number of kilometers times by 4. Okay, and now the number of kilometers is d times by 4. So 20 plus d times by 4. Okay, I'm going to write something down now. Just bear with me. Do you see that number there is the same? Do you see the same shading in the same places? Okay. Now, there's just one thing that I want to tell you with the algebra. When we write d times by 4, the way we write that shorthand is we write 4d. 4d means 4 times d. So 20 plus 4d. Okay, some of you have written 4d plus 20. Perfect as well. Okay, 4d plus 20. Okay, my phone is shouting at me and saying we must stop for a break. I want us just to do this one. I want us to just get an answer for this one before we have our break. This is working backwards. And I want you to go and look at what happened when we work backwards with numbers. We're going to do exactly the same thing. Okay, so the break is happening now, guys. I'm seeing right answers here. I'm seeing wrong answers. Skumbuzo, guys, we're having the break any minute now, okay? Skumbuzo, your answer's wrong. What Skumbuzo said, C divided by 4 minus 20. Now that's not, if you look at what we did up here, that's not what we did. What must we do to work backwards? What must we do first? What must we do first? We must, Naledi, it's not quite right. All right. We must subtract the 20 first. Okay. So guys, we're going to take the cost. We're going to minus 20, and then we're going to divide by 4. All right. Now we can also write, and guys, that 20, and I'm just going to use my green highlighter one more time. That 20 that we're minusing is that 20 that the taxi driver charges to come to your house. Okay. So, guys, the answer can be written like this, or we can write it like this: C minus 20 over 4. Okay. Both of those answers are just as good. But what you can't do is C divided by 4 minus 20. Okay, so Nortlanta, yours was correct. I think you had 2 C's by mistake. Wadile, yours was correct. Masle, yours was correct. Okay, all right. Okay, guys, so we're going to have a break now. All right, we're going to have a 10-minute break. Okay, it is now 11:37, so we'll start at 11. Can we do most of the work? Yeah, so guys, yeah, we're going to have a break now just for 10 minutes. Okay, so 11:48, we will start again. 11:48. Okay, right, we'll see you just now. Okay, someone's asked me to go to page 1. Okay, I can go to page 1. 11:48 is when we're starting. Page 1 there. Well, page 1's the cover, so I'm assuming you don't mean page 1. I'm assuming you mean page 2. Yeah, it's quite small to fit it all on. I'll open the mic for the break.
Yazili, I'm cooking.
Is the Lumkelo here?
Is here, Lumkelo is here. Who's
So.
asking?
Hi, Sus.
Yeah,
My name is Panel.
Oh, yeah,
Hey,
Zuzu.
wena Zuzu wena. Good.
Hi, Zuzu. Yeah.
Hi, y'all.
8B.
Hi, girl.
8B. Zuzu, don't speak like
B.
that.
Hi, 8B.
Asimake register 8B.
Hi.
Red one.
Kanyes, is that you? Yes, it's me.
Red one is here though. Red one is here.
Of course.
Hi,
Cellular.
I am
Hello,
here.
Sus. What are you
19.
calling me?
You want to direct number, guys. I need you want to direct number.
Asinokubanga here, but
Fuck off, send your hand, man. To 18.
who is that?
Zuzu.
Kaba.
Yeah,
That's
I
stay
need
here,
you want your
Sus. Stay
number.
here. I saw you log out
I space
logging every
Millie.
time, Sus.
Khona usiphe kahle.
Oh, don't misbehave, Lumkelo.
Can I please say, if you are here, Mtava, Kanyezi wants your number.
Hi, go. Hi, go.
He asked me on WhatsApp, asked to please give me Mtava's number.
Clever
Sus. Zondo. Hey,
Lindo, still.
Lumkelo. Lumkelo, can you hear me? Ah, she's gone. She's gone.
Kanyezi. Kanyezi.
Yeah.
How are you?
Yeah.
Kanyezi, I'm sorry. Let's go to Kanyezi. I'm so sorry, Kanyezi.
Sorry, one.
Kanyezi, I'm
Ay,
so sorry. Forgive me.
ay, 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 ay.
Apa kamu nanya sorry aku nanya.
Hey, B, show your faces.
Sandra, what are the actions?
Ukhona uNathan Dorrington la.
Hayi bo ulaphi? Ishondo uNathan.
Wait, Nathan is here. Hi, guys, stop lying.
Ukhona
Who wants to
uNathan.
think I know this picture?
Welcome to Zululand. Sunburn.
Yes, uyaphi break.
So my son. My son.
Where Sebuyi.
Wait, second, let me see in there, man. 1 minute left. Let us go.
Carry on. We're on page 9. Okay, and I just want to, you'll see that on page 9, I'm just going to start the timer again. So we'll go for 40 minutes and then we'll have our last break. Okay, and then we'll finish at 1 o'clock after that. Okay. The reason there's lots of blank ones here is that you can make these up yourself. Okay, so I'm going to do something like 5x minus 2. So obviously if I put x into there, I'm going to get 5x minus 2 out. Now I'm going to put some numbers here and I want you to try and work out what are the outputs, but I'm also going to put some inputs, All right. So for example, I'm going to ask you to work out that one. I'm going to ask you to work out this one. If that's an input, what's the output? I'm going to ask you to work out this one. If this is the input, what's the output? And I'm also going to ask you to work out this one over here. Let's go with okay. So I'm looking for right. Someone's asked page 14 and 15. Yeah, that's just blank pages in case I needed to explain anything to you. If we needed some more space. Okay. All right. Who can tell me what's my answer going to be if I put -2 into this machine? So now I need to do some integer work here. 5 times -2. Well done, Amashli. Yeah. Yes, I'm getting some correct answers, guys. 5 times -2 would be -10. Take away 2, -12. Okay, what if I put 4 in? What if I put 4 in? Well done. If I put 4 in, I'm going to get 18 out. What if I put 6 in? What if I put 6 in? Not seeing any answers for 6. There we go. I'm seeing answers for 6. All right. I get 28 out. What must I put in to get 38 out? All right. What must I put in to get 38 out? So we're working backwards. Well done, Melissa. Okay. We must put, and yeah, a couple of others, North as well. We must put 8 in. All right. And listen again to the language. And I want you to think about the getting dressed and the getting undressed thing. Okay. Multiply by 5, then subtract 2. Now we're going to go backwards. Add 2 and then divide by 5. Right. What must I put in to get 498 out? What must I put in to get 498 out? Well done, Melissa. I must put in 100. Okay, well done, Ogushe. Well done, Zimvelo as well. Yeah, all right. 100. Okay. Guys, because 100, when you multiply it by 5, you get 500 minus 2, you get 498. It makes sense. It always makes sense. Okay. Right. Now, guys, when you put x in, you get 5x minus 2 out. What must I put in if I want to get y out? So now this is moving from numbers to algebra. What must I do? I want to get y out. Okay. Simpiwe, that's not quite correct. No. 5x minus 2 is going that way. X becomes 5x minus 2. But if I want to get y out, what must I put in? Okay, it won't be 5y minus 2. I want you to think about what did we do here? What did we do to the 38 to get back to 8? And I want you to do exactly the same things. Right? How did we get there? We added 2 and then divided by 5. Added 2, not 2y. 2y means, guys, 2y means 2 times y. Well done. I'm now saying y plus 2 divided by 5. But remember, it must have some brackets. Guys, y plus 2 divided by 5. Have a look at this. 498 plus 2 divided by 5. 38 plus 2 divided by 5. I can write this as y plus 2 divided by 5, but I must have the brackets. Because without the brackets, okay, without the brackets, the order won't be right because the division would happen first, okay? Very proud of Ogushe writing y plus 2, then divide by 5. Okay. All right. So guys, yeah, this is just about practice. The more we get used to these, the better. But you'll see you've got some blank ones here that you can create one for your friend, all right? And then your friend can create one for you as well. And so then you can swap books and try them. Okay. We're now going to look at the next page. So page 10. Okay. And as I say, I know we're not doing all of it because we don't have time to do it all. All right. Now we want to start to learn. Okay. Someone's saying, please go back up. We want to start to learn how to write in algebra, how to take how to write an expression in algebra. Okay. So we're going to go now to page 10. Right, I'm just going to wait a little bit longer. I'll see Jabulo is okay. Hopefully Fundisiwe is as well. Okay, so yeah, so guys, page 9, there's examples that you can fill in and make up your own ones, okay? Because you notice I'm just saying, yeah, just make up some rules. So it's just space for extra practice. Page 10, guys, B is doubled and then 1 is added to the result. Now I'm going to write this like this, just so you understand. B, there's B, that's where we start. Now, double, okay? How do we write that mathematically? Well, how do we double a number? What do we do to it? We multiply it by 2. Okay, now, guys, this is really important. The way we write double B, we write 2B. Okay, 2B. Okay, we don't write B times 2. We don't write 2 times B. We write 2B. 2B means 2 times B. Okay, I know you might say, Paul, what about B2? Okay, we don't write that. We don't write that. We also don't write B2. And guys, we definitely don't write that. What does that mean? What does B squared mean? B squared means something completely different. B squared means B times B. Okay, all right. 2B is what we want. Then we're going to add 1. So now we're going to add 1. And what will our final answer be? Our final answer will be 2B plus 1. We can't simplify that. That's all it'll be. Okay. No. Okay. So, Elise, I'm hearing you say 3B. Okay. You can't add these two things. These are different types of things. Okay. All right. It's a little bit like saying 1 centimeter plus 2 millimeters, okay? Or it's a little bit like saying 1 dog and 3 cats. You can't add that. They're different things. Okay. All right. Okay. So, yeah, some of you understand what we call like terms. Okay. All right. So now let's see how we're going to write this. We're going to start with the next one. M. Okay. And it's going to be squared. Now, squared means times by itself. Now, remember, we started today with exponents. So that actually is how you write m squared. Okay? And then we're going to subtract 3. Well done. It looks like Melissa. Again, subtract 3. And the way we would write that is m squared minus 3. We can't do anything more with it. Okay. Then I want you guys to try and I want you to try and do C and D, okay? Okay, so we start off with X, okay? You see how, guys, I don't know if you see how I'm writing my X. I write it like that rather than like that. I know I typed it like that, but it's just easier to see that it's not a times sign. All right, so I'm seeing now, okay? I'm seeing X plus 4 . Okay, guys, if we add 4, we get X plus 4. Now, if we want to double this, all right, guys, we need to double. I'm going to show you two different ways we can write this answer. We can write it as double the number X plus 4, but we can also write it not as X plus 8, as 2X plus 8. Okay, 2X plus 8. Because, guys, if you double, you need to double both pieces. I'm going to show you on the side here. I'm going to show you a number. What is 3 plus 4? 3 plus 4 is 7. If I ask you to double this, you mustn't just double the 3 and not the 4. You must double the 3 and the 4. Okay, so if you've got double bits of a sum, so you've got X and plus 4, you need to double both of them. Okay, 2X plus 8 is 100% correct. Okay, let's do D. We find the square root of T. Okay, that we're just going to write like that. Then we add 15. So our final answer, just square root 2. Someone's asking me, square root T plus 15. Someone's asking me to move up a little bit. Okay, guys. Yeah, just if you're not understanding, just try and keep working at it. Don't make too many comments because they just distract everyone. Okay. We add 2 to T. Okay, now guys, when you add 2 to T, the answer is just T plus 2. Okay? You cannot say 2T. 2T means something else. 2T means 2 times T. And then we find the square root of the result. So we're now going to square root that. So it's going to be the square root of T plus 2. Okay, and then the last one. Multiply P by 4. And then subtract 3. What will be my final thing? What will I write in this one over here? What will go in here? Well done. Well done. It will be 4P yeah, I'm seeing, well done, 4P minus 3, guys. This here will be 4P. This will be 4P minus 3. No brackets, just 4P minus 3. So it's just very bright sun here. I'm just trying to make it a bit less bright. Okay. All right. Okay. Okay. Now, guys, we're going to do something. I'm going to ask you to do something here. All right. I'm going to ask all of you to think of a number. Okay. And I want you to write your number down. in this first box here. Okay, so you think of your own number. Then I want you to, yeah. So don't want you to give me your number. Don't want you to give me your number. Okay. Then I want you to add 5. Then I want you to multiply your answer by 4. Then I want you to subtract 8. Then I want you to divide by 4. And then I want you to subtract the number you started with. And I want you to do a couple of examples. Okay. So, all right. Okay. So, all right. So let's have a look. All right. It's in fact, I'm going to ask Oguhle. Oguhle, what number did you start with? Okay. We're going to do Oguhle's number. No problems, Indile. Okay. People ask what page we're on. We're on page 11. All right. Okay. Oguhle started with 8. Okay, Oguhle, I want you just to tell me your sequence of numbers now. What did you then get if you used 8 and you added 5? Just give me your numbers. Just I'm talking to Oguhle on the chat. So 8, then what do you get, Oguhle? Okay. People asking what page we're on. Thanks, Oguhle. Well done. 13. Multiply by 4. What did you get after that, Oguhle? Okay, I'm just, Oguhle, what do you get when you multiply 13 by 4? Okay. All right. Okay. Okay, my page 11 shows the table. Yeah, well done, Oguhle. 52. Carry on, Oguhle. What did you get when you subtract 8? Oguhle, subtract 8 from 52. Thank you, Oguhle. 44. I'm seeing other people giving that answer. Yeah. Divide by 4. That's hopefully easy. Okay, 11. And subtract the number you started with. Okay, so subtract the number you started with, you get 3. Okay. Now, guys, I want you to have tried your own numbers. Okay, so I'm going to do one for myself now. I'm going to take 3, add 5, 8, multiply by 4, 32, subtract 8, 24, divide by 4, 6, subtract the number I started with, I get 3. Okay, now I'm going to do another one. Okay, some people saying they don't have this page. Okay, someone's saying choose 7. Okay, all right, if I choose 7, add 5, I get 12. Multiply by 4, 48. Subtract 8, 40. Divide by 4, 10. Subtract the number I start with, I get 3. Yeah, okay, great question. Should we also use negative numbers? Let's use a negative number. Let's use -6. Add 5, -1. Multiply by 4, -4. Subtract 8, -12. Divide by 4, -3. Now, careful here. Subtract the number you started with. So -3, subtract -6. Guys, when we subtract -6, we add 6. So we get a final answer of 3. What does it look like here? It looks like all the answers are coming to 3. Is this magic? Okay. Every time it comes to 3. Okay, let's do +6. Okay, I'm going to squash +6 in over here. 6, add 5, 11. Multiply by 4, 44. Subtract 8, 36. Divide by 4, 9. Subtract the number we started with, 3. Guys, we seem to be getting 3 every single time. Okay, now, what we're going to do, okay, people ask me to do 16. Guys, I'll do 16, but I'm not going to do every number because we can't do every number because we'll be here forever. All right, 16, add 5, 21, 84, subtract 8, 76, divide by 4, 19, 19 minus 16, 3. We keep getting 3, okay? So, someone said, what about 1? Okay, let's do 1. All right, we do 1. I'll squash 1 in here. Add 5, you get 6. Multiply by 4, you get 24. Subtract 8, you get 16. Divide by 4, you get 4. Subtract 1, you get 3. Okay, now, I want to show you, now, guys, 81, I can do 81, but I'm not doing 81, okay? All right. Yeah. So, Nomfundo is saying, what? Crazy, okay? We always get 3, okay? Use 5, okay, I'll use 5 quickly. Okay, this is the last one I'm doing. If I use 5, add 5, I get 10. Multiply by 4, I get 40. Subtract 8, I get 32. Divide by 4, I get 8. Subtract the number I started with, I get 3. Okay, now, guys, I'm going to do it, but the number I'm going to use n. Any number, any number. N at 5, how are we going to write that? We're just going to write n plus 5. Okay. Now, who can tell me what will I get when I multiply this by 4? And remember, you must multiply both pieces by 4. Well done, Naledi. N plus 5. Now, what will it be when I multiply by 4? What will it be when I multiply by 4? I'm looking for anyone to tell me. When I multiply n plus 5 by 4. Okay, not quite right. Yeah, so bits of you're getting bits of it right. Someone's saying n times 4. Someone's saying n times 4 plus 5. We must multiply both pieces by 4. Ah, well done, Nomfundo. Okay, guys. 4n, that's that piece multiplied by 4. But we must also multiply this piece by 4. Okay. All right. Okay, I promise you 1,000 is going to work. Okay. All right. So the person who's written in, yeah. Okay. It's no problem if you're from Mexico. I don't know if you are from Mexico, if you're just teasing me. Okay. All right. Guys, someone wants me to try 1,000. Okay. Right. You can absolutely, yeah, okay. So someone said you can't put a variable before the number. Mihlali. Yeah. So you can, but we normally put the number first. Okay. All right. Guys, I want you to think about multiplying. Okay. I'm going to give you an example. Okay. Just oh, goodness, people asking when the break is. The break is 16 minutes away. Okay, we've got a while till the break. Okay. Yeah, we might have a break a little bit sooner. Okay. All right, guys, please let's try and stay focused. Okay. So when you multiply, I want you to just think about this. Let me give you an example. Suppose you've got suppose you've got, I don't know, 2 hens and 1 dog. Okay, and you want to multiply by 4. What must you have? What must you have? You must have 8 hens and how many dogs? 4 dogs. Okay, so what we're saying is when you multiply the n plus 5, this must be multiplied by 4, and that's 4n, but the 5 must also be multiplied by 4. Okay, now let's subtract 8. Who can tell me what will I get if I've got 4n plus 20 and I subtract and I subtract 8. What will I get if I subtract 8 now? 4n plus 20, and I'm going to minus 8. Yeah, dogs and hens are just example. Well done. Well done. Well done. 4n plus 12, guys. If you minus 8, okay. Now, divide by 4, guys. I want you to divide this by 4. But I want you to think about this. You need to divide both bits by 4. Both bits by 4. Who can tell me what will we get when we take 4n plus 12 and we divide both bits by 4? What will the new expression be? Well done, Nomfundo, well done. Okay. Uguhle, I'm saying 1n plus e. I don't know why e. All right. Okay. Well done, Wandile. Guys, it's going to be 1n plus 3. Do I need to write the 1 in front of the n? No. So I could write that as just n plus 3. Okay. All right. Now, what here? It says subtract the number we started with. Ogushle, no problem. Obviously, just a finger error typo. Okay. Guys, what happens now if I take n plus 3 and I subtract the number we started with? What number did we start with? We started with n. What if I subtract n now? What will I get? I will get 3, obviously. I want to say 5, okay? But I'll get 3. All right. Guys, I will get 3. And what I want to show you now, do you see that here we started with 16, here we started with 3, here we started with 7. Here we've started with n, all right? And it gets back to 3, no matter. So we've now shown that it will always get back to 3. All right, now there's another one that I want you to do, and I want you to make up your own number, okay? There won't be a remainder. It's a very good question. If the person who asked it, there's a remainder when we divide. Okay, so guys, if you started with P, okay, I'll show you what happens if you start with P. You get P. You add 5, you get P plus 5. You multiply by 4, you get 4P plus 20. You subtract 8, you get 4P plus 12. You divide by 3, you get P plus 3. You subtract the number you started with, you get 3. It doesn't matter what you start with. Okay. Okay, so someone wants me to try 10,000, okay? It'll work, okay? I'm going to bring up my calculator, all right, because just to convince you that it'll work. So let's start with 10,000. There's 10,000. Let's add 5. There it is, 10,005. Let's multiply by 4, 40,020. All right. Let's subtract 8, 40,012. Let's divide by 4, 10,003. And let's subtract the number that we started with, which was 10,000. There we go, 3. Okay. All right. Okay, now guys, I want you to try one of these. This is a new one, okay? And I want you to see what happens. I want you to do 2 or 3 examples and see what happens and see what you notice, because something interesting happens here. Okay, Tandisizwe, I'll explain it to you. Okay, this one's different, guys. This one, something interesting happens, but it's something different to last time. I'm going to do an example here myself. Okay, you do your own example. Okay, I've messed that up completely. Okay, I want you to see if you can notice with your own examples and my examples. Anyone tell me what seems to be happening here? Well done, Samkilisiwe. Yeah, well done. You seem, on this one, guys, we seem to get back to where we started. How weird is this? So let me try with 8. 8 subtract 2 is 6. Double your answer is 12. Add 8 is 20. Halve your answer, 10. Subtract 2, 8. Back to where we started. Okay, I'll do 50. Someone asked me to do 50. All right. 50. Subtract 2, 48. Double 48, 96. Add 8, 104. Halve your answer, 52. Subtract 2, 50. This one seems to get back to where you started. Okay, so now someone's asked me to do 0,7. I'll do it, okay? 0,7. Subtract 2, negative 1,3. Double your answer, negative 2,6. Add 8. Okay, it's going to be 5,4. Halve your answer, it's going to be 2,7. Subtract 2, it's going to be 0,7. Okay, now guys, I'm going... Wow, that's a great question. Samkilisiwe, please do N. N is going to be cool because N will show us if it always works. Let's do N. Guys, what will come next if I start with N? What will come next if I start with N? What's subtract 2? What's subtract 2? Well done, Nomfundo, keeping focus here. Right. Double that, guys. Double. And don't forget to double both pieces. Double both pieces. Well done, Nomfundo. Not 4n, Mandla, but Wandile, well, it won't be n minus 4. It'll be 2n minus 4. I need to double the n, and I need to double the minus 2. Well done, Sipiwe. Yeah, lots of you getting it right, okay? Right, who can tell me what happens now if we add 8 to this number? Careful, not minus 8, John. Not minus 8, add 8, huh? No, not 10n. Okay, we can't add 8s to n's, guys. We can't add 8s to n's. Well done. 2, no, not 2n plus 8. No. Okay, lots of people having a go. Guys, if you add 8, the 2n stays as it is. But what happens when you add 8 to negative 4? What happens when you add 8 to negative 4? Well done, Skumbuzo. 2n plus 4. Right. 2n plus 4, guys. Okay. Now, can you guys halve this answer? And remember, we must halve both pieces. What will half of 2n plus 4 be? Well done, John. It'll be 1n plus 2. I don't need to write the 1n there. I can write the 1, but I don't need to. Right. I can write it, or I don't have to write it. Okay, and now, guys, what if I now subtract 2? What will I be left with if I subtract 2 from n plus 2? Well done, John. I'll be left with n. And what we notice is it doesn't matter what I started with, I ended with the same thing. Okay, now, guys, I made these questions up, okay? I made these questions up, and you probably think, wow, how did you make them up? Okay, and I'm going to now show you, I'm going to go to one of the blank pages. You guys asked me why there was a blank page. I'm going to go to page 14, okay? And I'm going to make one up with you, and I'm going to show you how it works. Okay, so I'm going to make up one that ends in 7. No matter what you start with. Okay. It ends in 7 always. Okay. Now, guys, I'm going to all right, if you don't have blank pages, guys, this is page 14. It's just a blank piece of paper. Otherwise, just write on the back of something, find it. Okay, so I don't know how people don't seem to have page 14. Just this is a blank piece of paper, guys. So even if you don't have this, just watch. Okay. All right, I'm going to make up a table, and I'm going to have here the English. Okay, guys, I see lots of you don't have page 14. I don't know why you don't have page 14. Maybe whoever printed it for you just stopped printing. Okay, I don't know why. Okay, all right, but guys, okay, just guys. Okay, so all right, so a lot of you don't have. You can use anything, guys, just a piece of paper. And in fact, even if you just watch and don't write it down, just watch. Okay, I'm going to do algebra here. Okay. And then later at the end, we'll do an example. The break's coming soon. We're just going to quickly do one of these. Okay. Right. So the first instruction is think of a number. Think of a number. Okay. And my name is Paul. Okay. So I'm going to use P. P for Paul. But okay. Now, guys, I'm going to write down some algebra. Okay. And I'm going to see if you can help me work out what is the English? What is the instruction that we're going to give someone? Okay. So who can tell me what English have I applied if P has become P plus 2? What must I tell the person to do? The person who's doing this problem. Well done. Add 2. Thank you. Add 2. Okay. Lots of you. Yeah, people want me to go back to page 2. Okay. Allah. Yeah. All right. Now, okay. Can anyone explain what I've done to get from here to here? What have I done? What's the instruction if I've gone from P plus 2 to 3P plus 6? Well done. I've multiplied by 3. Okay. Now, can anyone tell me? All right, let's see if we can do this. Can anyone tell me if what I've done now? Okay, and I want you to look very carefully. What have I done to get from 3P to 4P? I haven't added 1. I've added the number that I started with. Do you agree? If I go P, if I add in a P, okay, so add your starting number. Does everyone see that? Because the starting number was P. Okay, well done. Okay, now, anyone tell me what I've done from here to here? What have I done to get from this line to this line? Well done, Naledi. So we've just added 2. Okay, now guys, I'm trying to think here. I want this thing to end with 7. Okay, all right. So I don't want 4P plus 8. I'm going to change this to P plus 2. Okay, we're going to have a break shortly. Okay, who can tell me what have I done to get from 4P plus 8 to P plus 2? Well done. Divide by 4. Okay. Who can tell me what have I done now to get from here to here? What have I subtracted? Okay, someone's saying minus P. Yes, but P is the number I've started with. I'm subtracting the start number. Okay, and what do you think the last thing I should do to get from there to there? Add 5. Okay, all right, guys, let's have a look. Let's test it. Let's test it. What starting number should I use? And don't give me something ridiculous, please. Okay, we're having a break as soon as we've tested it. What starting number should I use? 5. Okay, thank you for that. 5, add 2, 7. Multiply by 3, 21. Add the start number. So 21 plus 5, 26. Add 2, 26 plus 2, 28. Divide by 4. Now, guys, one of you asked earlier, what about, what if it doesn't divide exactly? Notice, guys, it will divide exactly because we can see it's going to divide exactly. Divide 28 by 4, we get 7. Subtract the number we started with. 7 minus 5, we get 2. Add 5, we get 7. This one that we've made up now will always end in 7. But I want to show you that when I created it using the algebra, because with the algebra, I can see what's actually happening to my number. All right, and I can see what I've got at any stage. Okay, if I was teaching you in a real normal classroom situation, I would be getting you to create some of these questions for yourself. Okay. All right, guys, we're going to have a break now. Now we're going to finish at 1. So we're just going to have a 9-minute break. Okay. And then because we're not going to manage to finish this whole thing. Someone asked me to go back to page 2. All right. So I'll go back to page 2 while we have the break. And then after the break, we'll finish off. So guys, we're going to start again at 12:40. Okay. So this is page 2. Okay, now right on here, start again at 12:40. So not a very long break, and then we've just got 20 minutes till we finish. Okay. Okay, guys, so we're going now to page 12. And we're going to look at some sort of statements in English, and we're going to write them mathematically, okay, with algebra. Right. So the number of months in M years. All right. So how many months will there be in M years? Now, a lot of people struggle with this because they say, well, I don't know what M is. Okay. But let's just think, how many months would there be in 3 years? How many months in 3 years? Well done, 36. Okay, now, lady, what did you do to 3 to get 36? What did you do to 3 to get 36? Now, lady, how did you get the answer? Yeah. Okay, Melissa's actually answered it for us. You multiply, and so is the lady. You multiply by 12. So what about 10 years? What will 10 years be? Yeah, 10 years will be 12 times 10. 120. Okay, so what about M years, guys? So now we're at the actual answer to this question. I'm going to highlight it in green here. How many months will there be in M years? M years. Okay, well done, Nomfundo. M times 12. Is there a shortest, better way of writing M times 12, Nomfundo? Well done, Wandile. 12M, guys. What does 12M mean? It means M times 12. Okay. All right. So Mateo, you're absolutely right. All of you writing Okay, Fundisiwe, we don't write M12, but I know that you know what you're doing. You're right. It is M12 means M12 also means M times 12, but we just write the 12 in the front. We write the number in the front. Okay. All right. Who can tell me with algebra, how will we write a number that is 6 bigger than B? 6 bigger than B. And if you're finding this difficult, you might want to think about, okay, so some of you are saying 6B. 6B is not right. 6B means 6 times B. That's not right. Okay, that's not right. Okay, well done. Some of you are writing B plus 6, 100%, or 6 plus B. Excuse me. Okay, now you might be saying, well, I don't know what B is, because if B was 5, right? If this was 5, then 5 plus 6 would be 11. Okay, sorry, I'm trying to mute myself while I cough. Okay, all right. So guys, B plus 6. A number half as big as A. Now, if you want a number half as big as a number, what must you do to the number? Okay. No, 2A is Kumbuzo. 2A means 2 times A. All right. Give me a number half as big as 6. What's half as big as 6? Half as big as 6 is 3. Well done, Shaheen. Well done, Nomfundo. Nomfundo is saying A divided by 2. All right. A divided by 2, guys. Not 2 divided by A or Gushe. Okay. 2 divided by A means something different. A divided by 2. Okay. Guys, we're going for 15 minutes and then we're stopping. It's 12:45. Okay. All right. Guys, I want to show you we can also write this as half A. This means half times A, half of A. All right. Okay. How big is P dozen? What is a dozen? What does a dozen mean? It means 12, eh? So if I've got P dozen, how big is that number? All right. And again, I want you to think, what if I've got 4 dozen? What would 4 dozen be? 4 dozen would be, well done to all of you who are writing 12P, guys. 4 dozen would be 48. It would be 4 times 12. But now we've got P dozen. It will be P times 12. But we don't write P times 12. We write 12P. Okay. So a couple is 2, and you've got 2 people, and you say it's a couple, all right? If I've got D couples, how many people have I got? How many people will I have if I've got D couples? What must I do to D to get the number of people? Well done, lady. Okay. If you are struggling with this, guys, put a number in here. Put a number in here. If this wasn't D, if this was 11, how many people would I have? I would have 22. Okay. And then ask yourself, how did you get there? Well, you got to 22 by going 11 times 2. So let's suppose it's not 11. Suppose it's 6. Well, if there's 6 people, it would go to 12. How did you get there? What did you do? You multiplied by 2. And so what we start to see as we get used to algebra, what we start to see is that we take this number and we times by 2. And if it's 11, we times 11 by 2. If it's 6, we times 6 by 2. All right. And if it's D, we must times d by 2. So the answer will be d times 2. But do we write d times 2 like that? No. Do we write 2 times d like that? That's better, but we don't even write that. We write what Naledi and Fundisiwe are writing at the moment. Okay, and Nomfundo. We write 2d. 2d is the best answer, the best version of the answer. Okay, now think carefully about this. A number 9 less than g. Okay, and I want you to don't rush this because a lot of you are going to get, okay, I'm seeing two different answers there, and I'm seeing wrong answers and right answers. Okay, 9 less than g. So guys, think of g. If g was 12, what would our number be? What would our number be? Our number would be 3. Does the answer 9 less than g is not 9 minus g? The answer is g minus 9. Here's the answer. G minus 9. That's a bit confusing. I'm going to give you a little bit of time just to think about it. All right? Okay. Because what's confusing is because the less than, we think, oh, we must subtract 9. Okay. G, this is G here. Here's G, this blue thing, right? And to get from the blue thing to a number 9 less, we must actually take the blue thing and minus 9. We mustn't go the other way around. We must take the 12 and minus 9, okay, to get the 3. Okay, so we must take the G and minus 9. Okay. All right, guys, it's definitely G minus 9. 9 minus G will not work. Okay, because if you put a number in place of G, you'll see it doesn't work. Okay, how do we write double T and then add 5? How do we write that mathematically? Well done, Melissa and a few others. 2T plus 5. Okay. Multiply K by -2 and then subtract 2. Well done, Skumbuzo. Okay. -2K. All right, that's multiplying K by -2 and then subtract 2. Okay. How many people will there be if we've got G soccer teams? Now, remember, in a soccer team, there are 11 players. 11 players. So if we've got G, okay, so Wandile, I'm seeing G plus 11, and that's not right, okay? Because suppose I had 4 soccer teams. Wandile is saying 4 plus 11. That's wrong. Okay. What do I need to do? Well done. I need to multiply by, I'm not sure where G33 comes from, lady. All right. Okay. I need to multiply by 11. Absolutely. I need to take my G and multiply by 11. But what's the shortest way of writing that? The best way of writing that is 11G. Okay. And now we're going back to something that we looked at earlier, and that's earlier we had hens and sheep, but now we've got elephants and ducks. How many legs will I have altogether? Altogether, okay, the total number of legs. Okay, I'm not sure if that 8 is an answer to the elephants and the ducks. Definitely not. Okay, what? Yeah, no, not E plus D. Okay. Okay, Melissa, that's nice, but we don't write it quite like that. Okay, we don't write it quite like that. Okay, I'm not sure which one I'm going back to. Okay, okay, I'm saying for I am seeing the right answer. Okay, guys, here's the strategy. Let's put numbers in here, 10 and 3. And I promise you, you will all be able to do this question now. Okay? Well done, lady. All right. What must I do to get the number of legs on the elephants? Well done, Ngushle. Okay. Guys, what must I do to the number of elephants to get the legs? I must multiply this by 4. What must I do to get the number of legs on the ducks? I must multiply by 2. Each duck has got 2 legs. All right. And then I must just add the legs. Okay. So guys, I'm going to highlight here. This is the number of elephants, and there it is. This is the number of ducks, and there it is. Okay. So the answer would have been 46, not 56. Okay. Yeah, 46, yeah. Okay. But guys, for our particular thing, it'll be 4 times the number of elephants. And the reason it's 4 times the number of elephants is each elephant has got 4 legs. And then however many ducks we've got, we need to multiply that by D. So there's our answer for our legs on our ducks. Okay. Okay, so I'm saying go back, and I'm not sure go back to where, to which question. Very happy to try and help, but I don't know where I must go back to. Yeah, the answer for this one is 4E plus 2D. That's the answer. We can write this one as we could write it as 2D plus 4E. Okay, right? But we always write, if we've got a number and a variable, we always write the number first. Okay, all right. And so, guys, we are going to stop there. I want to just quickly talk to you about just a little bit about kind of what I do while I've still got my screen shared. Okay, so I'm a teacher, and I just teach one class at the school where I work. Okay, and with the rest of my time, I run with my sister. I run something called SIMI. Okay, which is the Shaizi Balo Maths Initiative or Institute. Okay, and we've got a website, and I'm putting the. Someone's asked me to go back to question D. I'll do that just now. Okay. I'm going to put the website address in the chat. It's just SIMI, SIMI .education. Okay. And so you'll see the website's on the screen now. Okay. Now, if you go down here, there are videos for the whole of grade 8 to teach you. Okay. So if you go to the library here, this year we're working with grade 8 and we're working with grade 12. Okay. We have workbooks for each term. So, but now you can see, for example, if you want to know about fractions, there's a video for each